Welcome to our course on Maven. In this lesson, I'm going to give you an introduction to the course, and we will talk about the course content as well as what you will learn throughout the course. To begin, let's discuss Maven. Maven is a build automation tool. You may be familiar with something like Ant or Make, and those are both build tools. We use them to take our projects and construct some deliverable that we can then use or deploy. For example, we can create a jar or a WAR file from our Java projects, and Maven is a tool that automates that process. Now, the unique thing about Maven is it looks at building a project from a different paradigm. It emphasizes convention over configuration, and this really provides some additional benefits from the tool, and it delivers other features such as dependency management that really revolutionize how we build our projects. Maven is a project underneath the Apache Software Foundation umbrella. It's managed by the Apache organization, and they have been a stalwart within the Java environment since Java has become very popular. You know you're getting a quality project. It's managed by a great group of developers that are really promoting Java and have the best interest of the language in mind. It was created in 2003, so as of right now, it has been in existence for about 12 years. We also know it's a very stable tool that you can use and introduce into your toolbox. You don't have to be afraid that it's too cutting edge or maybe it's going to fall off. An investment in Maven is an investment within a stable tool that you can use to improve the way you build your applications. The current version of Maven is Maven 3.3.1. Early on in the 1.x series of Maven, there were some concerns, and many developers established a love-hate relationship with the tool. Since Maven 2, that has really subsided, and the tool has been viewed a lot more favorably, and it's gained a lot more adoption, especially now that it can be integrated with other continuous integration tools. Let's talk a little bit about the content of the course. What are the different chapters we're going to be looking at? What are you going to be learning? First, we're going to start off by giving you an introduction to Maven. This is just kind of that general getting to know you piece with the software. We're going to give you key terms, the key goals you're trying to achieve with the software, the key components that make it up, a discussion of how it works, just so you have a little bit of knowledge of how the tool is going to help you build software. From there, we're going to expand, and you're going to learn about dependency management and dependencies within Maven. We'll move on to discuss the lifecycle, the goals, the plugins, and this is really how Maven performs its different actions against your project. So how it builds an artifact from your simple Java project. Next, we'll talk about archetypes, which are really project templates that can help us generate projects more quickly and to create some reusable project that we can share across our organization. Finally, we'll talk about the M2E Eclipse plugin, and this is some integration within Eclipse that helps us when we're working with Maven. These are just some of the topics that we will cover and some of the things that you'll learn about throughout the course. Obviously, there are a lot more details under each one of these topics, and we're going to really dive in to looking at the tool and working a lot of hands-on demonstrations and examples. So let's talk about who this course is for. This course is primarily for intermediate Java developers. Now, if you're an advanced beginner, you'll also do fine within this course. While Maven is targeted towards all languages, it is primarily a Java tool. In theory, it could be used with something like .NET or C#, and that wouldn't be a problem, but the ecosystem has really lent itself to Java developers. The tool is very good for people that have a large project or a portfolio of projects that they need to manage and standardize. It can really add some organization and kind of just add a layer of consistency to these portfolios or large projects. Now, it can be used within any size project, and I would even advocate for that, but the individuals that will see the real benefit are these large project managers or portfolio managers. Also, if you are a heavy user of third-party libraries, So I'm talking to the Spring users, the Hibernate users, these frameworks that have other dependencies upon dependencies upon dependencies. This is the tool for you, and you really need to take this course and dig in and see how it's going to help you manage those third-party frameworks that you introduce into your applications. So what do you need to know before taking this course? Well, the first item is a general Java background. You should have some experience building classes, compiling classes, and running Java applications. We will not be delving very heavily into, we're going to create this class and constructors. It's more just making simple test classes that we'll use throughout the course. Also, any experience you have with Java IDEs such as Eclipse, we use Eclipse throughout the course, mainly because it's the most popular Java IDE. That's going to be beneficial as we work throughout the lessons. Next, XML is very important throughout this course because we use XML to configure Maven. You will see that we have a pom.xml file, and that's the configuration file read by Maven, and it primarily uses XML. We will cover more on that later in the course, but just know that XML experience is beneficial. And then finally, I have listed command line experience. Now, this isn't a heavy prerequisite, but we will be using the command line for a portion of the course, and any familiarity you have issuing commands via the command line will help you throughout the course. I'm really excited about this course. I think it's going to be a great learning experience for you. You will find I don't like to PowerPoint you to death. There's a lot of hands-on demonstrations because I find that's the best way to learn a new technology. So let's talk about what we're going to cover in this chapter. As you would expect, this is an introductory chapter to Maven, so we're going to be looking at some high-level concepts surrounding the tool. The first objective for our chapter is to introduce the Maven tool and discuss some of its benefits. We're going to be covering what Maven can do for you and why you would want to use it, and hopefully this can give you a good overview of whether Maven is right for you and your project. Next, we will talk about the major components that make up Maven. There are some key principles and parts of the tool that it's important we understand, because as we begin to work with the tool, we're going to put these key components to work for us when we build our projects. Now, after we cover those key components, we're going to talk about how they work together to build a functional tool. You'll see that there are some different relationships between these components, and together they make up the complete Maven picture. Next, we're going to go hands-on, and we're going to install Maven and Eclipse. And we'll be using these tools throughout the course to learn how to work with Maven and to demonstrate some of the principles of Maven. So after we've installed our tools, then we're going to go into a simple Hello World demonstration. And this is the first time that you will see Maven in action. We'll go over a simple use case for Maven just so that you can see how the tool works and how you would interact with it. It will be our first taste of working with Maven. In this lesson, we're going to have some conversations that start to wrap our minds around this tool called Maven. These conversations will lay the groundwork for the remainder of our course. Let's take a look at what Maven is. You'll see that these first 4 bullet points kind of have some details about what we can expect from Maven. We're going to discuss each one of these bulletin points in detail later in this lesson. The first thing we see is that Maven is a build tool. So you might be familiar with something like Make or Ant. And we know that these tools take our source code and generate some sort of library. Maybe it's a jar file or an ear file or a war file, but they package up our code into that distributable library. Now, moving on, Maven is also a dependency management tool, and this is the favorite feature of many Maven users. We build these applications, and these applications rely upon third-party libraries. So maybe you use Spring or Hibernate. Well, using Maven, we change the way we obtain those dependencies and the way we manage them. Next, we'll talk about how Maven is a project management tool. Now, this isn't one of the strongest project management tools I've seen, but Maven does allow us to include some information about the software we're building. such as the version number or maybe who is working on it, and it also provides just a good overview of what is being used within our project. Next, we see that Maven provides a standard approach to building software. This is kind of a theory behind Maven. If we have 5 projects we're building, and we are using Maven in each one of those projects, we will see a consistent approach to each project. And that gains us some efficiencies just because the projects are so consistent. Now, I have 2 more bullets here, and they're simply to show you how we use the tool. Maven is primarily a command line tool. So you open up a command prompt and you have Maven on your path and you're issuing commands to Maven and it's doing some sort of work for you that helps you build your application. So that's one way. But we can also use the IDE. There is integration for major IDEs such as Eclipse or NetBeans, and we'll take a look at that later on in our course. So let's take a closer look at build tools, because if you don't understand a build tool, you won't understand Maven. We talked about how there's this primary goal of taking source code files and making these deployable artifacts, so our jars, our wars, our ears. That's the primary goal, but there's also a lot more to that. Maybe we have certain other steps that go along in our build. Maybe we want to run some unit tests. Maybe we want to generate some Javadocs. There's all sorts of things that we could want to occur when we build our software products. It's important that when we perform that build, we hit all of those steps. And the best way to do that is to have an automated build process or something that is repeatable. And that's where our build tools come in. They allow each developer to essentially kick off the same build. It's not manually performed, so we know steps are not missed, and we know that a developer can easily come onto a project, and as long as they know how to use our build tool, they can essentially build the project from source. So we get some advantages there. Now, what you'll also see built into a lot of build tools and into the build files is that our artifacts are then sent off to a server in the case of a war or an ear file, or you can also store that artifact like a jar file somewhere where it can be obtained. And these are all things that Maven does as a build tool. Now, you may think, well, that's great, but I can step through and compile my classes in my IDE, and I can use the Java compiler to compile. I can use it to build myself a jar file or a war file. Well, the idea is to step back out of your IDE or from using those rudimentary tools and put it into one tool that can be used by any developer. So maybe you're using Eclipse and you're able to build a jar file using it, but somebody else may be using NetBeans. You're both able to build a jar file, but the idea behind a build tool is to make the build IDE agnostic and to make it repeatable. Now, one of the great things about Maven is there is integration with other build tools like Hudson, like Bamboo. So by using Maven, you can then in turn work with other tools that are going to provide you with other benefits. So let's move on and discuss dependency management. As I mentioned, this is one of the most popular aspects of Maven. We talked about pulling in something like the Spring Framework. When we use Maven, we reach out to an online repository and we pull down the framework from that repository. So we don't have to go out and search on the website and download the jar file and pull it in. We can do that through Maven. Now, the great part about that is if the library we're pulling in, let's say Spring, has defined its own POM file, then we know Spring's dependencies. Because just like our application depends upon Spring, Spring can also depend upon other libraries. And when we use Maven, Maven will reach out and grab the dependencies of our dependencies. And those are known as transitive dependencies. And then we'll also see a thing called dependency scoping within Maven. Sometimes you may not want to use a dependency at a certain point. So maybe a dependency I use in my tests is not used when I actually deploy my web application. So you can specify the scope of a dependency and that will conditionally include it at certain points. Moving on, there's also this project management aspect of Maven. And it's pretty simple. We have a POM file, which we'll talk about later, but it's an XML file. and it can list pretty much all of the information we need to know about our project. And some of the things we can specify are the version of our project, the developers on the project, the website for the project, so we can kind of catalog that information. You also see that we can reach into source code repositories and we can generate change logs depending upon the diffs between different versions of our source code. Maven can also be used to generate documentation about the software we're developing, and this is all automated during that build process. We can also create Java documents that will provide information about the code that we have developed. So if we're developing a library that other people are going to be using, a Javadoc could be a very useful artifact for that individual. Also, we can generate reports that give us all sorts of information about our project. So maybe we run a Clover code coverage report, and that can tell us what has been tested, what hasn't been tested, and those are all useful from that project management perspective. Now, finally, we're going to talk about how Maven is used to standardize our builds. So as we discussed, if we have multiple projects using Maven, there's this uniformity across those projects. And the way it's achieved is through patterns. Now, don't go off and think about like factory patterns or build editor patterns. This is very simple. It's kind of having like a standard directory structure, so Maven knows where we're going to place different things. And this leads into convention over configuration. Maven is opinionated. In Ant, you may say, well, all of my source code is in this directory. Maven's approach is you're going to place all of your source code within this directory. So it dictates a lot of the structure of our project, and that achieves a lot of conformity across a portfolio of projects. So you're going to see a consistency throughout them. And you're also going to see a consistency in the path taken to build these projects. So it believes strongly that there is going to be a compile phase, a test phase, a deploy phase, and those are going to appear in the lifecycle of every project. And we're going to discuss the lifecycle a little bit later, but it's just good to introduce this concept now so you have an understanding that a lot of Maven projects are going to look the same and they're going to follow the same processes, have the same type of layout, and that's really where the power is in Maven. And this leads into the philosophy of Maven. Now, there's a very short article on Maven's website that basically describes their motivations for creating Maven. And it was actually kind of because they had all these Apache projects. So Maven is an Apache project, and it was created because all of the Apache projects were kind of different. If I was a developer on one project and I moved to another, I had to learn a completely different build system, and it might be laid out differently, and Maven was created to solve all that. So I would urge you to go into your working files and follow the link to the philosophy of Maven. As we move forward in the course, we will explore a lot more of these topics in detail. In this lesson, we will discuss the Maven Landscape. The Maven Landscape is all of the components that make up the Maven application. So in this lesson, we're just going to touch on each of these components. That way, when we encounter them during our course, you will have some context before we actually take a deep dive on each of these components. The first one we will discuss is the Project Object Model, or the POM. Now, the POM is an XML file, and this file really describes the configuration and the customization for our project. So it's going to spell out the different plugins, the different dependencies, and the different profiles that we use to construct our project. Now, within this POM, there will also be an address. Maven uses a coordinate system where you specify an artifact ID and a group ID as well as a version number. And this actually creates the address for an artifact. You'll see this comes in handy when we try to retrieve these artifacts from a remote repository, which we'll talk about a little bit later in this lesson. So when we refer to the POM, we are talking about an XML file that contains all of the information that Maven needs to build our project. Moving on, let's discuss repositories. Repositories hold all of our different artifacts and dependencies. So we can have our dependencies, which are kind of like our libraries. So if we would pull down Spring, that would be considered a dependency. And then also artifacts can be found within our repositories. And artifacts can be things such as plugins, they can be jar files that we have built, they can also be archetypes, which we'll discuss a little bit later. But basically, you can reach out and pull down any of these objects. Now, there's two flavors of repositories. One is the local repository, which resides locally on your machine, and it's part of the Maven installation. So when Maven gets installed, you're going to define this M2 directory, or it may be defined for you. And this is where Maven will store all of the dependencies or artifacts that you pull down from a remote repository. A remote repository is a repository that we access via some sort of protocol. So maybe we go out through HTTP and we pull down a jar file. So let's say the Commons lang jar, we access that dependency through the Maven Central repository, which sits somewhere out on the web, and we're accessing it and downloading that dependency. Well, that dependency that comes from the remote repository will then get stored within our local repository. So we're going to have a local copy. It's almost like a cache. Because if we reached out and tried to use that dependency again within, let's say, another project, we're just going to use the copy that we have within our local repository. So the local repository is going to take precedence over the remote repository when we perform dependency resolution. When we think of a repository, just think of a collection of artifacts or dependencies, and they can be local and remote. So some of them may not be on your machine, they may be out in the web or somewhere out there for us to grab, or they may reside locally within your repository if you've already fetched them from a remote repository. One of the things I've touched on here with repositories is that we can pull down plugins. So at that point, you should be asking, well, what is a plugin? It's pretty simple. A plugin is a collection of goals. So now the question is, what is a goal? Well, goals are the actions we perform. The example is the compiler plugin has two goals. There is the goal to compile your source and also to compile your test. Imagine it almost like a class. The compiler plugin acting like a class, and let's say it has two methods on it. And the methods would be compile source and compile test. That's kind of an analogy you can use from the Java world to understand plugins and goals. You could almost think of goals as methods, these actions that we execute to perform our Maven builds. These are the operations that we're going to be performing against our code base to build a product. So all the work that we do with Maven is done through plugins and goals. Now, we can call the plugins and goals in different manners. You'll see in a little bit that there is a lifecycle within Maven, and this lifecycle has different phases. Each plugin and its goals can bind to a particular phase in a lifecycle. We can also call a particular phase in a lifecycle independently. There's two approaches to calling a goal and performing some sort of action against our project. So let's talk a little bit more about that lifecycle that we are binding these plugins and goals to. Well, the lifecycle is just a named sequence of events. You can think about anything as having a life cycle. One of the earliest life cycles that I learned about was actually a butterfly. It starts out as a larva, so that's the larva phase, and then it makes a cocoon, it's in the cocoon phase, and then it turns into a butterfly, and that's a different phase. And software is no different. When we build software, there are different phases we have. So there could be the compile phase, the test phase, the install phase, the deploy phase. And all of those are going to be part of a larger life cycle. And Maven has three life cycles: clean, default, and site. Now, default is by far the largest of these life cycles. I believe it has about 23 phases within it. And that's where our plugins are going to bind to these different phases. So as we execute the default lifecycle and we enter into the compile phase, we are going to kick off the compile sources goal on our compiler plugin. And that's kind of how Maven works in a sense. We execute those goals and those plugins when they are tied into the lifecycle and into these phases. Now, one thing I mentioned is that we can execute goals and plugins in two different ways. One way is to bind to the lifecycle. Well, there is a sequence to each phase in the lifecycle. And when we call a phase that is later in the lifecycle, so let's say Maven Deploy, which is the last phase in the default lifecycle, we are going to execute every previous phase. So it's just important to know when you're calling these phases via Maven that you are going to be calling every phase that has preceded the phase that you are executing. So this is just an overview of the different components that kind of make up Maven, and they're going to be crucial as we move along in the course. This lesson will deliver a technical overview of Maven. We know that Maven consists of several different components, such as the POM, the dependencies, and the plugins, as well as the lifecycle. But what we haven't seen is how all of those components interact to help us perform our builds and to deliver artifacts that we can then use. So the way we begin normally is by issuing some command to Maven via the command line or through the Eclipse IDE plugin. Here you see I am executing the install phase of Maven. So I'm working on the default lifecycle here, and I'm calling the install phase. We're going to take a look at what exactly happens when we fire off this command. Now this will just be a high-level overview, but as we work with the tool, you'll be able to refer to this high-level picture to understand exactly what's happening. Once we fire off that command to execute the install phase, Maven is going to examine our pom.xml file. And it's going to read through this file to learn more about our project and what we need to perform a build. Some of the important pieces of the POM that Maven will be inspecting is the project information. So that is those coordinates where we're actually going to create an address, a way to find the artifact that we're going to create with this build. It will also look at the dependencies and the plugins. So our dependencies are those libraries that our application may refer to, and the plugins are going to be the actions that are going to occur against our source code to build this artifact. We know those plugins have goals, and that's how the build takes place. They're kind of the verbs, so any actions that we perform against our source code. In order to obtain those dependencies or plugins, Maven uses its Dependency Manager. And the Dependency Manager looks at the dependencies and plugins listed within the POM, and then it goes out to the different repositories. Now, if we don't have the dependency or plugin within our local repository, the Dependency Manager will reach out to all of our remote repositories that we have defined. Now, this is repositories like the Maven Central repository, the Nexus repository, so it will have different remote repositories and their locations specified, and that's where it will go to find any sort of artifact that we don't have locally. It's going to pull in our plugins and our dependencies. So now we have those things available. Once they're available, the lifecycle will begin, and we will start by executing the compile phase. Because we called the install phase, we would need to execute every phase preceding install. There are several that I haven't mentioned, but just for this simple example, we're just going to go with compile, test, and install. So the compile phase would execute. And if there are plugins that correspond with the compile phase, they would execute within that phase. Here you see our red line indicates that our first plugin has goals that correspond with the compile and test phases. So those corresponding goals would be invoked within those phases as we step through our life cycle sequentially. Next, you would see that our second plugin would be called during the install phase because it would correspond to that lifecycle phase. So this is just a visual representation of kind of what's going on underneath the hood when we perform a Maven build. And it all boils down to basically the POM specifying all this information, our dependency manager going out, pulling in the items we need, so our plugins, our dependencies, and then as we step through the life cycle, we are executing the appropriate goals on the corresponding plugins for the life cycles. And then we also have our project dependencies in place, so goals like compile can take place and occur successfully. If you ever need to look back and kind of get the bigger picture for Maven, you can consult this diagram and hopefully it will help you as we work through the course. In this lesson, we will install the Apache Maven tool on our local machines. This will allow us to work through all of the examples within the course. To begin, we're going to navigate to the Maven website, which is located at maven.apache.org. And once we are on the website, we will navigate to the download section. So you'll see the link to download Maven on this left-hand navigation panel. Simply click the link, and on the download page, you will see the different versions of Maven. Here we see the current version of Maven, which is Maven 3.2.5. Now there are different distributions of Maven depending on what we would like to do. If we would like to modify the source code of Maven, we can download one of the source distributions. It's provided as a tar file and a zip file, and Maven is open source, so the source is available to us. We're not going to be changing any of Maven's source. So we're just going to use the binary zip file. Simply come over to the link and click on the link, and it will prompt you to download the software. It is distributed within a zip file, and we'll just have to extract that on our system to install. Now, one thing I'd like to point out is that Maven has a very small download size. It is 7.7 megabytes. But there are plenty of plugins out there from Maven, and we can also access many dependencies. Well, those plugins do not come packed within Maven, so they are not included within the installation folder. But given Maven's dependency manager, it's able to reach out and grab the plugins it needs. And that allows it to have this small distribution size, yet still have the ability to use numerous plugins. So I have already downloaded the zip file to install Maven, so I'm just going to cancel this download and we'll head to my desktop where I have placed the Apache Maven 3.25 bin.zip file. So that's everything we need to install. I'm going to extract the file to my desktop and I'm going to place it within my software directory, and that's where I keep all of my development software. So there we see the Apache Maven 3.2.5 directory, which has been extracted. And then within that directory, we have a readme.txt file. And if we open that guy up, we will see that there are some installation instructions within this file. So here you see the directions for installing Maven. And it's pretty simple. There's 5 steps, and we've already completed 2 of them. So we need to unpack the archive, then we need to extract it, and then we place the bin directory on our path. So that's the step we're on, and that's the next one we will complete. If you double click on the bin directory, you can then grab this path and copy it to your clipboard. And now we're going to navigate to our computer screen, and within the computer screen you'll see the system properties. Simply click on those system properties, and then you will see the advanced system settings on the left-hand side, and then we can specify our environment variables. Now, the environment variable that we are concerned with is the path on the system environment variables. Now, the path is where Windows looks for programs that we have placed. So when we execute something within a command line, Windows will look on our path to see if there's a program that can execute the given command. So what we're going to do is simply end our path with a semicolon, and then we're going to paste that path to Maven's bin directory on our path environment variable. So once that's in place, we can click OK, and that will add that directory to our path, and it's now available when we want to execute a command within Windows. Now, one important thing is that you have the Java JDK on your path. Installing the JDK is pretty simple and it's outside the scope of this course. It's assumed that you would have that knowledge prior to entering this course. So just make sure that you have Java installed prior to installing Maven. So just click OK and click OK once again. And at this point, you should have Maven installed. To validate the installation, open up a command prompt, and within the command prompt, type mvn-version. And this will display the Maven version, and it will allow us to confirm that we have properly installed the software. So you'll see that we received the Apache Maven 3.25 version. It specified our Maven home, which was that bin directory that we put on our path, and it also spit out some information about the Java version that we are using. So with this information, we can be sure that Maven was installed properly. In this lesson, we will download and install the Eclipse IDE. In our lessons, we will be using Eclipse in order to present how to work with Maven. Now, while Eclipse is not required to work with Maven because Maven is IDE agnostic, it would be required to follow along with our lessons exactly. Now, if you're comfortable in another IDE, you are free to work with that IDE, but our lessons will not be exact for your IDE. However, if you're using Eclipse, you will be able to follow along step by step. So I'm going to show you how to download, install, and configure Eclipse. The first thing you'll do is go to the Eclipse homepage at eclipse.org and just click the download link, and then you'll be presented with some options. Now, I like Eclipse Luna and I need the 64-bit version, so I'll just click on the 64-bit link. And then I always pull down from the Penn State mirror because that is closest to my home and my alma mater. So we'll click on that link, and here we will be presented with the option to download the file. Now, I have already downloaded the file and I've placed it on my desktop, so we will just do the installation from there. It's pretty simple. You get a zip file and you just need to extract it. So I'm going to extract that zip file to my desktop. And now that it has extracted, I'm going to go in and rename this folder to Eclipse Luna SR1 because this was the first service pack. And I'll just close that window and I will paste that folder to our desktop and I can delete that old folder. This is just some cleanup. And then within that directory that we have unzipped, you will see the eclipse.exe application. Just double click that application and this will open Eclipse for the first time. The first time you open Eclipse, you will need to specify a workspace, and the Eclipse workspace is simply where all of your Eclipse projects are held. I'm going to select the Browse button, and I'm going to scroll up to my desktop, and under my desktop, I'm going to make a new folder and title that folder Eclipse Luna Workspace. And then I'll double click that folder and hit OK. And I will also set the option to use this as the default and not ask again. And once I have those settings in place, I'll click the OK button and we'll continue opening Eclipse. Okay, and we see Eclipse is now opened. I'm just going to size it up a little. And the first thing I'll do is close our welcome window, and this will open up the main Eclipse window, and we see our editor, our project explorer, and our outline. Now that we have Eclipse installed, we're going to add a plugin to Eclipse. And to do that, we can go to the Eclipse Marketplace, and we're going to look for the TCF Terminal plugin. So once our marketplace initializes, we can perform a search for that plugin. And what this is, it's a terminal plugin, so it'll allow us to basically have a command prompt within Eclipse, which is a nice feature, and it will help us as we work with our lessons, so we don't have to switch back and forth between a terminal window and Eclipse. So here we see the TCF terminals 1.3 for Luna SR2. I'm going to go ahead and install that. So I'll just hit install, and now I will check that I want to install the terminals view, and we'll hit confirm. And we'll see that Eclipse will download the software, and eventually we'll be asked to restart the software. The main reason we have Eclipse is so that we have an editor just to work with our different XML files that we will be modifying as we work with Maven. So now we see that the plugin has downloaded, and we simply need to check the radio button to accept the license. So check accept and then click finish. And once the software is done installing, we will have to restart Eclipse. Okay, so simply click yes to restart. And now that Eclipse has restarted, we can go in and open our plugin by clicking Window and then Show View and then navigating to Other. And within Other, we will find the Terminals plugin. So make sure you are using the plural form of terminals. The remote systems terminals is not the one we would like. That's actually built into Eclipse and it's a little bit different. So just double click on that view and you can actually pull it up into your editor if you would like. And then all we need to do to open a terminal is click this Open a Terminal button, and we just want a local terminal. And then to make sure everything is working, you can simply type dir command prompt command just to make sure that you are connected to a local terminal. So we will be using this throughout the course to execute our Maven commands from the command line, as well as to modify the XML files that we'll be using with Maven. In this lesson, we will get our first exposure to Maven by compiling and packaging a simple Maven project. In order to walk through our project and to use the command line in sync, I have chosen to present this lesson using the Eclipse IDE. So you'll notice on the left-hand side of our screen that we have the Package Explorer, and the Package Explorer is showing the Maven Hello World project. Now, this is a simple directory that you will find within your working files. So you can choose to pull this into your favorite editor. Maybe it's Eclipse, or maybe it's something else like NetBeans. It doesn't matter. It's just a simple way to look at all these files as opposed to looking at them through the file system. The first thing you'll notice about our Maven Hello World project is that we have a source folder, and that source folder is named Source Main Java. And within that folder, there is the Hello World class. And you can see on the right side of your screen that the Hello World class is pretty simple. It's simply spitting out Hello World. We're not very concerned with the functionality of the Hello World class. We're just concerned with compiling it using Maven and then packaging it into a jar. If you focus on the left side of your screen, you will also notice that we have a pom.xml file. And this file will be in the root directory of every Maven project. And if we take a look at the pom.xml file, you'll see some different elements within that XML file that tell Maven the information it needs to compile and package our project. First, you'll notice that there is the root project tag, and that will be the root tag of every pom.xml file. After that, we specify a model version. And the model version is used to indicate what version of the object model this POM is using. So this does not change very often, but for the version of Maven that we're using, we need to use the 4.0.0 model version. Next, you'll see that we have specified an artifact ID, and that artifact ID is specified as maven-hello-world. This is simply the name of the artifact that we're going to generate with our project. Next, you'll see a group ID, and this element indicates the unique identifier of the organization or the group that is creating the project. So these are simply qualifiers. You will use these artifact IDs and group IDs to pull down plugins and dependencies. So this is that address or coordinate system that we talked about with Maven. And then the final piece of that is the version number. And here we're just specifying a simple version of 1.0. Now, if we were working on a project under development, this is usually suffixed with snapshot. And then sometimes you'll see release as a suffix when we are actually putting out a release for general availability. The final item that you see is the packaging element, and the packaging element indicates the type of packaging that we will use for the artifact that we produce. Something like jar, war, ear, it gives Maven some clues about what it's trying to produce when it builds our application. That's an overview of a very simple Maven project. And now what we're going to do is we're going to switch to the Terminals tab, which is simply a command line, and run some commands in order to build our project. So I'm just going to maximize that window, and we'll get started by running our first command, which will be mvn package. So this is a pretty simple command. We're specifying mvn, which indicates that we would like to use the Maven tool, and then package is a phase within the default lifecycle. And this phase will create a jar file that contains the contents of our project. Now remember, every phase that precedes package, such as compile and test, will be executed when we specify the package phase. So let's go ahead and run this, and we'll check out Maven's output. So there we see that it tells us we're building, and let's just scroll up and take a closer look at some of this. Here it tells us it is building our project named Maven-hello-world, and it's version 1.0. Here you see it pull down a plugin. So it's looking at the resources plugin. Here we see the compiler plugin, and we also see that it's executing the compile goal. Here we see that the source file, which was the hello world class, getting compiled by Maven. And if we scroll down, then we should see our jar file being created. There is the Maven jar plugin, and we are executing the jar goal, and that is creating this maven-hello-world-1.0.jar file within the target directory. If we were to return to the package explorer, and we would now refresh our project, we see that this target directory is created within our project and that we have created this artifact, so this jar file that contains the contents of our project. And you'll notice the naming convention on that is the artifact ID dash the version number. You'll see that convention being followed when you compile these different artifacts. This was an example of the power of Maven. So with just a few lines of XML and one command that we simply ran on the command line, we were able to build our project and produce a jar file. I hope you enjoyed your first exposure to Maven. There's plenty more to learn, and we will cover a lot more advanced topics in our future lessons. This chapter is named Building a Project, and that's exactly what we're going to look at. We're going to look at how you put that architecture in place for your project in order to use Maven. We're going to look at some different techniques that you can use to structure your projects or to configure your projects. So let's take a look at what we're trying to achieve within this chapter. This will be our first hands-on working chapter. You're going to get your first hands-on experience with Maven and begin to set up Maven projects. So the first thing we're trying to do is put that basic project in place. And what you're going to see is there is a standard directory layout that we must follow, and that's very important for how Maven performs its work. You'll also see how to construct a POM and put some of the basic information about your project into a POM. After that initial project is created, we'll then move on to look at how you can share some configuration between projects. So we may set up a super project and then have several projects that inherit from that project. And we do that using POM inheritance. So this is a way to have some reusable configuration, and it can help you maintain the configuration that you'd like to remain the same between your portfolio of projects. Next, we'll move on to look at how we can modify projects using profiles. Within one particular project, there may be many configurations that we need to put in place, depending upon certain circumstances. Maven provides a profile that can be applied when we are working within a particular environment. And this allows you to provide kind of on-the-fly customizations to how you build your project. So we'll take a look at how you can set those up and use them within Maven. And then finally, once we have gone over kind of the rudimentary methods of creating projects, so how to lay out those directories and how to build your POM file by hand, we're going to move on and take a look at a plugin, the Archetype plugin, that is going to help us quickly generate a project within Maven. This is going to be a great chapter. It's going to be your first hands-on experience with Maven. Let's get started. In this lesson, we will create a simple project that we can use to learn about Maven. This project will help us as we perform our different demonstrations throughout the rest of the course. So to begin, we're just going to create a new project within Eclipse. Now, you could create this project through your file structure, but we're going to use Eclipse. The first thing to do is hit Control and then press N, and this will bring up the New File dialog. And within that new file dialog, you just want to type Java project and then simply hit next and give your project a name. We're going to call this Maven Examples. And then once you have specified the project name, simply click Finish. Now, if we look at our project, we see that Eclipse has placed a source folder within the Maven Examples project. What I'd like you to do is to delete that source folder, and we're going to create a new source folder. So once again, we can hit Control N, or you can right-click on your project, go to New, and then select Source Folder. Now, I always prefer using Control N, and that's what I'll use throughout the rest of our course. The one thing we need to specify for this source folder is its name. So I'm going to specify source main Java. And once that's specified, I'll simply click Finish, and now we have our new source folder. Within this source folder, we're going to place a class. So simply open up the new dialog and type class. And we'll put this class within a package. So here in the package text box, I'm just going to type com.infiniteskills.maven. And I'm going to name this class Application1. And once I have that information specified, I'll simply click Finish, and we have our new class. Now, the next thing we're going to do is add our POM file to our project. And this is very important within a Maven project. And we create that within the root directory. So having the root directory, Maven Examples, selected, I'm going to open the new dialog, and this time I'm going to type XML. And we can simply select the XML file and hit Next. And we're going to specify the name of our XML file as pom.xml, and we'll hit Next. And now we're going to create an XML file from an XML schema file. So we're going to specify an XSD file. And this will define the structure of the XML document we're going to work with. And in this case, that's the pom.xml. So once we select the XML catalog entry, you will notice that Eclipse has a number of predefined XSD files, and they will define the schema for our XML files. So if you scroll down through this list, you'll notice that we have some XSD files that apply to Maven. And the one we would like is the http maven.apache.org/xsd maven-4.0.0.xsd. This is the XSD file that must be specified for Maven 2 and 3. So once we have that file selected, we can hit Next. And now the next thing I'd like to do is just have our root element not have a prefix. So we're going to click on this line where it has the namespace information, and we're going to click Edit. And then we're simply going to remove the P prefix. And now you see that we have no prefix. After that's complete, we click Finish, and you'll notice that our pom.xml file is then added to our project. So with these two new files created, we need to add some content to them. The first one I will modify is application1.java, and all I'm going to do is add a main method to this class, and then I'm going to print out hello world. That way we just have some for code within that class. And now we're going to switch over to our pom.xml file. And I'm going to go down and click on the Source tab, and here you'll notice that the root element is this project element, and we've actually defined a namespace, so we're pointing to a location that will describe this XML file. And there we see the schema location, and that's pointing to our XSD file. So I'm going to drop the closing project tab down to another line, and the first thing we need to specify is our model version. And for Maven 2 and 3, the model version is 4.0.0. This needs to be included within every pom.xml file, and then there are 3 other tags that need to be included within this XML file. These are the only required tags. The first one is the artifact ID, and for this we're just going to specify our artifact as Maven examples. Next we specify the group ID, and we're going to use com.infiniteskills.maven. Now you'll notice we're using periods almost like a package declaration for our group ID, and that's perfectly acceptable. However, that convention is discouraged when using the artifact ID. Next, we're going to specify our last mandatory XML element, and that is our version, and we're simply going to put 1.0.0. And with all this in place, we are then able to compile our files. Now that everything's in place, let's head to our terminal, and we're going to run a test. So we'll open a local terminal, and I'm going to now navigate to our working space. And within that space, I'm going to navigate into the Maven examples directory. I'll maximize this so we can see it a little bit better. And from here, I'm going to issue a simple Maven command. So I'm just going to issue mvn compile. And let's see if everything is set up correctly. Okay, so we had build success. We see that one source file has been compiled. And if we return to our project, we can then refresh our project directory, and we see that the target directory was created, and within that directory we have our class file. So excellent. We've set up a simple project that we can use to explore Maven. Within our subsequent lessons, we will expand upon this example, and we will use it to illustrate more advanced concepts. When working with Maven, we know that there are required pieces of information that we must place within the pom.xml file that describe our project. For example, there are 3 required artifacts that really make up those coordinates. So the artifact ID and the group ID, which serve as almost an address, and then the version ID, which almost serves as a timestamp. Well, there's other pieces of information we can provide about our project that will be helpful to those that are working on the project with us or after us. So for example, we saw the packaging element, and the packaging element just says what type of artifact you would like to build. So you can specify a jar, an ear, a war. Well, by default, this element is going to say we are going to build a jar. So if we're just trying to create a jar file, I don't need to include the packaging element. Now, that's more of an operational piece of information, what type of artifact are you trying to build? But we can also provide just more informational types of elements within the pom.xml file. So for example, we can provide an informal name for our projects. If I was talking about this project with another developer, I wouldn't call it Maven-examples. Maybe I would call it something like Learning Maven Examples, and that's how we would informally refer to our project. Now, we can also include a quick description about our project. And that can be useful for anybody trying to get a quick understanding of what our project's about. And if we had a website established that contained information about our project, we can also specify that. So let's just say we had a website, and that's where we would go to obtain more information about this project. Now, when we build an application, we normally include licenses. So you can specify any license information about your project. So any licenses that it includes, you can specify its name. So let's say we're using the Apache license, and you can also provide some comments. Okay. And some other pieces of information you can provide are also helpful for just pointing out who has worked on the project. It's a good thing to know if you're coming onto a project and none of the original team exists, kind of who started it off, because they can be additional areas that you can use to gather information. You can specify the organization that is behind the project, so who's supporting it. So in this case, we're just going to put Infinite Skills, and you can include their URL. And another important piece of information you can include is who are the developers on the project. So we use the developers tag, and within there, we specify the developer tag. And within that element, we can specify things such as the name of a developer. And then there's a few other elements we can specify, such as your organization, the URL of your organization, any roles you have, and your time zone, and we'll just specify my email. Okay, so there we've provided some additional information within our pom.xml file that can give somebody a good overview of our project. Now that's great, but you may be saying, who's going to go in and read my XML file? Well, that's a good point. So Maven provides an additional feature where we can take this information and build a website. I'm going to go to my terminal and simply type nvn site. So I'm calling the site phase within the site lifecycle. And here we see that Maven starts generating some reports and starts building a website for us. Now, if it's the first time executing this phase within Maven, it's going to reach out and grab a bunch of the plugins. So your execution of this task may take a little bit longer than what you've seen on my screen because you need to go out and pull down those additional plugins. I already have them on my machine. So my machine executed a little bit quicker. But what we can see after this has executed is that if we are to refresh our project, then we notice that within our target directory, there has been this site folder created. And what we can do is we can go to the index.html file, right-click it, and then hit Open With, and then Web Browser. And you'll notice that we have this website that is about our project. So look at our project license. Here you can see that we have specified the Apache license, and there's our comments. If we look at the project team, there we see my name and email, and we put that within our pom.xml file. And we can also look at the About section. So there's a description of our project as well as the name. And you can look at the project summary. So there it shows the website of the project as well as the organization. And it also contains those coordinates that we talked about for locating our project. And what you'll actually see under our dependency information is a little bit of XML that you could actually put within your POM file. And when we talk about dependencies later in the course, you'll get very accustomed to specifying this XML structure within the POM. So in this lesson, we learned about how to include a little bit more information about our projects, and we saw how that information can then be transformed into a website by Maven. In this lesson, we're going to discuss Maven's standard directory structure. Now, the best way to begin to elaborate on this topic is to show you a quick example and then ask you a question. The first thing we're going to do is we are going to execute the compile phase. So I'm just going to type mvn compile on our terminal, and once we kick off that phase, we see that Maven will compile our classes. So if we refresh our project, we see we get this target directory, and the single class within our project is compiled. So application1.java turns into application1.class. Let's go back to our pom.xml file, and I'm going to ask you a question to get you to think about this. How did Maven know where that class file could be found? If we look at our pom.xml file, in no place within the pom have we specified any directory containing our class files. Well, the answer lies in the convention over configuration theory. Maven relies upon convention over configuration. So instead of specifying the location of our Java source files, we simply place our Java source files within a predefined location that Maven uses as a standard. And this is known as the Maven standard directory layout. So here is Maven's website, and this lists all of the directories within the standard layout. You'll notice that here is the source main Java directory, and that directory is known to Maven, and it will search it for our Java source files. Now, there are several other directories that are included within this standard, such as the source main resources directory, and this is a commonly used directory, and you would place all of your configuration files, so maybe like a log4j.xml file, or if you had some properties file that you'd like to read, that's a good place to place those types of files. Now, you'll also see when we're building a web app that we'll use source main web app, and this is basically going to be our web root. So it would contain things like our JSP files, all of our CSS, our JavaScript, any HTML, anything pertaining to that web application would go within that source folder. Now, other commonly used directories include the source test Java directory and the source test resources directory. And we commonly use those directories when we're running our JUnit tests or any other tests for our project. You'll also notice that within the directory structure, there is also a license.txt file and a readme.txt file. You can use those to relay information about your license and also anything you'd like to put into a readme file that may help anybody looking at your source code. Now, the other directories are not used as commonly. You won't see a lot of projects pulling those in, but you may encounter those at different times, and you can always come visit the Maven website, just look for the standard directory layout, and you can get more information about those directories. Now, I'd like to return to Eclipse, and we're going to run a quick demonstration. And in this demonstration, we're going to look at how we can change some of those standard directories if we were ever working with a legacy project. Now, Maven allows you to configure the directory for certain things, such as where it looks for the source files, where it places the class files, where it looks for your resources. You can change all of those by specifying a configuration within the pom.xml file. Now, it's not recommended to do that if you're working on a new development project. But if you're trying to incorporate Maven into a legacy application, you may need to specify those directories. To demonstrate this, I'm going to add a new source folder. So I will open up the new file wizard, and then I will select the source folder, and I'll hit next. And now we need to specify a folder name. So I'm going to use source non-standard /Java. And I'll hit finish, and that will place that source directory within our project. And then I'm going to create a new class, and we'll give this some simple packaging. And we'll just call this application2. and we won't put anything within that class. So I'll actually just close it. And now what we're going to do is we are going to tell Maven to use that source folder to look for our Java sources. And this is very simple. Within the pom.xml file, we can use the build tag. And within the build tag, there are a number of different directories that we can specify. So here you see the source directory. So that's the directory that contains our Java source files. Now we can also specify the test directory. So there's our test source directory. That's where it would look for our test. And you'll also see that we can change the directory that we're going to write the files out to. So let's just change the source directory, and we'll just specify source / non-standard and then / Java. And we're also going to have this printed out to a different directory. So we were outputting all of our class files to target, as we see here within our package explorer, but let's put it out to something else like my target, just something different so we know that our test will work. Okay, so what I'm going to do now is I'm going to head back to the terminal with those items in place. And one thing I want to mention before we head over to the terminal, you'll notice that I am using relative paths here. You can use a fully qualified path, so something like C:/ users Kevin Bowersocks, and then have a fully qualified directory to where your source is contained. But when we use these relative paths, we're going against the base directory. And when we're using Maven, the base directory is considered the directory that is housing our pom.xml file. In this case, it is the root of our project. So before we run our demonstration, let's do one thing. Let's delete our target directory within our project. And now we're going to head over to the terminal, and I'll clear out the terminal. And now we're going to execute the compile command once again. So we're executing that compile phase with Maven. And there we see that we have built our classes. And if we were to refresh our project, we see that we now get this my target directory. And within the my target directory, we have compiled application class 2 because it was found within that directory that we specified within our pom.xml file. So that is a way that you can customize some of those standard directories within Maven if your application demands it. But as we discussed, it is much better to stick to that standard directory structure. In this lesson, we're going to discuss POM inheritance. So when we talk about inheritance, a good analogy to help lay the foundation for our discussion is the Java concept of inheritance. Within Java, we know that we can have one class be derived from another. For example, we know we can have that parent and child class relationship. And when we have that inheritance relationship in place, the subclass or the derived class inherits some of the properties or methods from the parent class. Well, we have that same concept taking place within Maven. One POM file can be derived from another POM file using inheritance. And in that situation, the configuration within the parent POM is then carried over into the child POM. Now, within the child POM, we can override some of the configuration specified within the parent POM. So another way POM inheritance corresponds with Java inheritance is that every POM inherits from a super POM, much like every class in Java inherits from the object class. So let's go find the parent POM and just take a look at the types of configuration specified within it. So if you go to where you have installed Apache Maven, just navigate down into the lib directory, and within the lib directory, you will find the maven-model-builder-3.25.jar. And if you open that jar with, say, WinZip or 7-zip, what you'll see is that there is an org folder, and then within there Apache, then Maven, then model. And then you'll notice that there is a pom-4.0.0.xml file. And that is actually the super pom. So I've just double clicked that and you see that it is now open within Eclipse. So just scrolling down, these are some of the configurations that will be carried over into all POMs that extend the super POM. And eventually every POM will extend this POM. These are those default configurations that really create the convention over configuration principle for Maven. So there you see the central repository is listed as one of our repositories. We'll talk a little bit about that later. But you'll remember the build section. Here you can see where it is establishing the Maven standard directories. So there's source main Java, there's source main tests, and also we see that there is source main resources. So these are those default configurations that each of our POMs are inheriting. There we see some plugins, there's some reporting that's built in, and then a few profiles. Now another way to see this is to navigate to a terminal, and here we're looking at the Maven examples project that we have set up. So that was this POM that we are looking at. And if we want to see the entire POM, the child POM with the inherited super POM in place, what we can do is run Maven help and then effective-pom. And here we'll see the entire POM for our project. So I'm just going to open up our terminals tab so we can get a better view at this. And here you will see that all of the specific information for our child POM, such as the group ID, the artifact ID, and the version, has been merged with all of the configurations specified within our super POM. So if you would ever like to see your entire POM, you can always run the mvn help effective POM command. Now we're going to run through one more demonstration. Each POM file can also inherit from another POM file that we built. So not only can there be inheritance to the super POM, you can inherit from another POM. And where we see this happening a lot is when an organization will develop basically a standard POM that should be used across their portfolio of projects. So we're going to take a look at how we can build one POM and then have another POM inherit from that POM. Let's go back to our pom.xml file for our Maven examples project. Let's configure this POM to inherit from another POM that we have created. So the first thing that we need to do to inherit from another POM file is to add the parent tag to our pom.xml file. And then within these parent tags, we need to specify the coordinates of the POM that we would like to inherit from. So I'm going to open up our parent project, and within its POM, I'm just going to grab the artifact ID, the group ID, and the version ID. And those coordinates will allow me to inherit from that POM file. And since the group ID and the version ID were already specified within the parent POM, I'm going to remove those from our child POM. So at this point, we have set up inheritance. So let's just take a look at the parent POM quickly. Here you'll see that we have included some information about the product, the name, the description, the URL, the license, the organization, and the developers. So if we head back to our terminal, the first thing we can do is install our parent POM. Just use mvn install. Type that into your console. And what this will do is it will take our Maven parent POM and it will put it within our local repository. So there we see that our POM file was placed within our repository. There you see my repository at M2 repository, and then here you see the group ID begin to be built out, and also then that POM file gets placed within the local repository so that when the Maven examples POM references it, it is available to be inherited from. So having that put in place, we can now look at our effective POM once again. So I'm going to clear our console and I'll head over to the example And now we'll clear this console. So right now we're sitting within that child projects directory. And I'm just going to run the effective pom command once again. And now when we see this pom, you'll notice that the information from the pom we created is now pulled into our new pom. So let's find some of our developer information. There we go. So here, that developer information that was specified in our parent POM is now inherited within our child POM because the child POM is now derived from the parent POM. This is another way that you can go about organizing your POM files, and it can be very helpful to create that parent POM that holds all of the boilerplate information that you would like to include in every POM, such as what is your organization, who are the developers on a project, any licensing information. It can be really handy to have that just in one spot so you can modify it in just one place instead of modifying it in every POM file across your portfolio of projects. When creating a project build, we want that build to be portable so that our project can be built upon many different environments. Often within our organizations, we work where there are many different environments. We have our dev environment, our test environment, and our prod environment. And we need to customize the behavior and configuration of our build in order to be able to deploy to those different environments. There's usually a custom set of properties for each environment that we are working within. Maven profiles allow us to build our projects for those different environments. It gives us a mechanism to customize our builds depending upon the environment we are targeting. So within our POM file, we are able to specify a profile which will define an alternative set of configurations for a particular environment. To get started, we're just going to add the profiles tag within our POM file. And the profiles element can contain one or more profiles, and within that profiles tag, we're going to specify the profile tag. And then each profile must have an ID. So I'm going to create a profile with the ID of production. That's great. We created our first profile, but what can we really do with it? Well, looking at our POM, we can see that we have within the build tag, we've specified a directory. And this is actually the directory where our artifact for the Maven examples project, which we have on the left here, will be deployed. So let me expand our editor window, and we see that full directory, and we see that each time we build this Maven examples project, our jar file is going to be placed within this development directory that sits on my desktop. So what we're going to do is within our profile, we're going to override that. So maybe now we're on the production system and we would like this artifact to be placed in some other directory. Maybe we have some file transfers that go on and we need to have a particular directory for this jar file. So within the profile, you can actually override the things that you would specify within the normal POM. Most of the items available within the POM that you can modify are available within the profile. So here we see the build tag, we see dependencies, we have the repositories here. So pretty much anything that is accessible via the regular POM is accessible within the profile. So we'll use the build tag, and we're just going to specify a different directory. So I'm just going to copy our directory tag, and now I'm going to call it production. And we'll save our file. Now let's run a simple demonstration to show these profiles in action. The first thing I'm going to do is just run a normal package, and this will create that jar file that we have within our project. And if we go look at the artifact destination directory, this was that directory specified within the POM file, we see that a jar file was created and placed within that development directory. Now I can go back to the console and I can clean that up. And now we're going to specify a profile. And the way to do that is to provide a flag. So it's -P, and then specify the name of the profile that you would like to apply. And then you specify the goal. So we're going for the package phase. and we're applying the production profile. So we should write that jar file out to that production directory that we created. So let's run through, and I can tell it already worked because we have this directory. But let's head over and just check it out for our own eyes. There we see it. So that's great. And let's clean this up. And now we'll head back to our POM file after I clear the console. We were able to apply the production profile that we created, but there's more to this story. We won't always want to define the profile we'd like to apply by using that command line flag when we execute a goal. Sometimes it's not possible to specify that flag, or we just want to take a different approach. Maven provides us with a mechanism to take other environment characteristics into consideration when we determine which profile to apply. And this is known as an activator. So an activator is a way to look at something else. So maybe like an environment variable, and look at that environment variable, see maybe what its value is, and then determine by that value what profile to apply. So let's take a look at activators. I'm just going to navigate below the ID tag, and we'll use this activation tag. Once the activation tag is expanded, we see that there are 5 different activators we can apply. You'll see activate by default, you'll see file, JDK, the operating system, and the property. So file looks at whether or not a file is available or if it's absent, and we can determine to apply the profile in that manner. JDK considers what version of Java you're using to build with. The OS is the operating system you're working on, and then property looks at those environment variables. So we're going to go ahead and use a property. And when we specify a property, we need to provide a name and a value. These are the 2 pieces of information we must know about our environment variable. And what I have done is I have already set up an environment variable on my machine named package_env. So I'm just going to copy that variable name, and we're going to use it within our pom.xml file. So for the name, we need to prefix any environment variables with env, and then we'll use the package_env name, and I'm going to specify a value of prod. So what will happen is when Maven executes our package goal, it will see this activator within the pom.xml file, and it will notice the environment variable name. It will go out and consult that environment variable, and depending upon the value, it will then conditionally select a profile. So let's save our POM file, and now we'll navigate to the terminals command, and we will execute the package goal. Now, you'll notice that I have not specified any command line flags here telling Maven to apply a particular profile. Now, by default, we would have applied the development profile, and we would have wrote our artifact to the development directory. But since we have the environment variable activator set up, we will write to the production directory instead. So let's execute this phase. And there we see that we built our jar, and it was placed within that production directory. So we were able to use that activator to customize our build. And that's the whole point behind profiles, is customizing your build for an environment. In this lesson, we're going to look at a way we can expedite the creation of a Maven project. We know that we can manually build out our directory structures that conform with the standard directory layout, and then we can place our pom.xml file within our project. And we can do all that with the file system pretty much. But once you understand those details, and I'm a firm believer that you should understand those small details about any technology you're using. You should know how to manually perform some action within the technology you're using, because it only comes back to help you later when you're debugging some other issue. But once you have that basic understanding, there is a plugin provided by Maven that can really increase how quickly you can build a project. And that plugin is the Archetype plugin. And on that Archetype plugin, there is the generate goal. So from the command line within our workspace, notice we're at the root of our Eclipse workspace. We're just going to execute that goal. And what you'll see is that Maven is going to go out and grab a bunch of archetypes. And archetypes are predefined projects. They're templates that you can use to build your own project. Now you'll see that Maven went out and pulled down, it looks like 1,273 of those archetypes. And they're coming out from the Maven Central Repository, so they're out on a remote repo, and it's asking you to pick one of those. Well, we're not really interested in any of these that it's listed. We're interested in just the Maven Archetype Quick Start, which is the default, and it just lays out a basic project, much like we have already created. So you can just hit enter and that will accept the default. The next thing it will ask is what version of the archetype would you like to use? Just like our projects that we've built within the POM file, we specify the version. The archetypes also have a version. Now, by default, Maven will pick the latest version, which is 1.1, or you can actually just specify the number as 6. So the next thing you'll see it ask us for is the group ID. And this is just like when we're building our pom.xml file. We need to specify those coordinates for our project. So I'm just going to specify com.infiniteskills.maven. And that will be our group ID. And now it's going to ask me for an artifact ID, once again defining more of those coordinates so our project could be located within a repository. And I'm just going to go with more Maven examples, and I'll press enter. And now it wants to know the version of our project, and I'll just go with 1.0. You see the default there would be 1.0-snapshot. And now it's going to ask for a package. Now, we really haven't seen this within the pom.xml file, but what it's asking is under your source folders, which it will build according to the Maven standard directory layout, it's going to also include packages. And we all know that we normally use our domain name in reverse to specify a package to make it unique. Now, it's giving us a default, which matches our group ID, and I am fine with that, so I'm just going to hit enter. And then it's just going to confirm. It wants to know, do you want to build this? So just hit yes. And now, if I look inside my Eclipse workspace, now you'll see the more-maven-examples directory, and I can cd into that. And within that directory, you'll see that it's created a pom.xml file, and there is also a source directory. What we'll do is I'm going to use another plugin and another goal. This is the Eclipse plugin and the Eclipse goal. And what this will do is it's basically going to turn this project into an Eclipse project. So it's going to give it a .project file, everything we need to pull this guy into Eclipse. So I'm going to execute that. Now, I have already downloaded that plugin through some of the examples I have worked. So you didn't see it on my screen, but right now you're probably having that Eclipse plugin being pulled down from a remote repo. And that's one of the nice things with Maven. You didn't have to specify anything other than, hey, I'd like to use this plugin. And Maven says, oh, that's great. I'll go out and find it for you. Contrast that with some of the times like when you would like to use a jar file in the past. You probably went out, downloaded it, pulled it in, make sure it's in the right directory. All we did was say, I would like to use this, and Maven worked with us and complied. So once we've ran that Eclipse goal, then what we can do is we can import that. So I'm just running the import option in Eclipse, and you can just hit Alt F and then I, or you can go File, Import, and within there we just want to import an existing project from our workspace. And then we're going to look in the root directory of our workspace, and within here we should see more Maven examples. And we'll select that and then just click Finish. And you'll see it pulled in that project so we can work with it within Eclipse. And there you see source test Java, source main Java. That should be looking familiar. Those are the Maven standard directories. And it also created a POM file for us. And if we look at the source of the POM, there you can see it has actually specified our group ID, artifact ID, version ID, the packaging. It also provided that name, the URL. It was a very quick way just to set up a Maven project, and once you understand the finer points, I would recommend using this Archetype plugin to build your projects. It's going to save you some time and make things a little bit easier on you. So it's time to move on to our next chapter, which is all about dependency management. So in this lesson, I'd just like to take a look at the chapter and the items that we're going to cover. But first, let's talk about what dependency management is. Dependency management is pulling in the different libraries that you need for your application or for your project from a repository. Now, this repository can be located on your machine or it can be located remotely. So what you'll see happen is within your POM file, you're going to specify the coordinates of a dependency, and Maven will go check your local repository to see if that dependency exists, and if not, it will head to the remote repository to pull down that dependency. That dependency will then be cached within your local repository. Let's move on and look at our chapter objectives. Dependency management isn't very difficult, and you'll see that when we run a demonstration of using a basic dependency, that there's not too much we need to specify and that Maven does most of the work for us. So that's our first demonstration. We will see how to pull down a simple dependency for our project. Now, after we pull down that simple dependency, we're going to learn how transitive dependencies work within Maven. Now, when we talk about transitive dependencies, we are talking about the dependencies of our dependencies. So the classic example is Spring relies upon a bunch of other jars that it uses, and we need to have those on our path at runtime. What Maven is able to do, it's able to look at Spring's POM and then go out and grab the dependencies associated with Spring. Now, if one of Spring's dependencies also had other dependencies, they would also be pulled into our project. The days of going out and learning all of the dependencies of a particular library and downloading them from a website are over. That is going to occur in an automated fashion for us, and Maven is responsible for that. Now, one thing we will see is as we pull down more dependencies and there are more and more transitive dependencies within our projects, sometimes conflicts can occur. And we're going to learn how to manage those conflicts so that we can get the appropriate libraries that we need for our project. One of the areas that we will briefly cover during this chapter is working with remote repositories. Normally, when we pull down our remote repositories, when working with Maven, we are accessing the Maven Central Repository, and that holds a large number of dependencies or artifacts that we can use within our projects. But sometimes we need to use an artifact that is not found within the Maven Central Repository. So what we need to do is find a repository that does have that artifact. And once we find that repository, we need to include it within our configuration. Then we can reach out to that repository and find the particular artifact that we need for our project. And then a final item that we will cover within this chapter is Dependency Scope. By applying scope to a dependency, we can determine the lifecycle phases that it will be available for. Not every dependency is needed in every lifecycle step. For example, if I have JUnit in my project, I don't need that when I'm in the runtime environment because we're not running unit tests while we're running our web application at the same time. They are normally run at different phases. After I compile, maybe I want to run my unit tests, and if they fail, then I stop my build. I would not need those sitting out on my class path somewhere on Tomcat or with a web server. So we're able to specify these different dependencies, and we can specify their scope, and that determines when they will be available. So this is going to be a great chapter. Dependency management is one of the strongest features of Maven, and it really draws in a lot of folks to start using the tool. It will really change how you develop. You will feel more comfortable pulling in additional libraries into your project just because that ease of use is there now. You no longer have to worry about the different dependencies that those libraries that you're using have. So it really opens the door for a new paradigm of development. One of the greatest strengths of the Java programming language is that we can rely upon third-party frameworks or other open source libraries to build our projects or our applications. This is a great strength because you get a piece of code that's already been tested, it's already been vetted through a number of developers, and there's usually been a collaborative effort to build this piece of high quality code. And you can just pull that into your project and use it without incurring that initial development cost. One problem with this model in the past was that you needed to know exactly what version of a particular library you needed, and then you had to go out and find that library on the web or through some other repository where you could download it. Well, Maven has centralized all of that work into its dependency management system. And this is my favorite part of Maven. If it weren't for the dependency management system, I probably wouldn't have gotten on board with Maven. It has caused me to really buy into this tool, and so many others have bought in because of this dependency management feature. It really reduces the complexity of your work and the complexity of managing the different libraries that we leverage within our projects. Within this lesson, we will learn how to use Maven to pull down the dependencies within our project. So we'll start out by taking a look at our pom.xml file for the More Maven Examples project. And within this pom file, you'll notice this dependencies tag, and this is expressing the dependencies within this project. So these are the libraries we're using. And currently we are using JUnit. And you'll notice that we are specifying the coordinates of this dependency. With that information, Maven knows exactly what library or what dependency we need to pull into our project for it to compile or properly run its tests or to execute properly when we're running the application. So in order to take a further look at this, we're going to run through a quick demonstration. One of the things I have done is I have built out an application. It's very simple. It takes some input from the user and it asks for that input to be non-numeric. We then inspect the input to see if it's numeric, and if it is, then we provide a message saying, hey, this string is numeric, and if it's not numeric, then we say the string is valid. So you'll notice that I have stubbed out an isNumeric method. Because you know what, maybe I just want to use some other library to perform this logic. Something tried, true, something tested. So I go out to the web and I try to figure out what I need to use. And I get pointed to the string utils class within the Commons Lang library by Apache Commons. So I go down through and I see that within this class, string utils, there is an isNumeric method, and that sounds like exactly what I would like. How do I get this dependency or this library, Commons Lang, within my project? Well, the answer is we need to go out to a remote Maven repository. And we're going to use the Maven Central Repository. So you can go to search.maven.org. And what we'll do is we're going to search for commons-lang. And I'm also going to include that I want this from Apache. So I'll put org.apache. So that's kind of the package naming. And what you'll see is that here we get some artifacts that are available within the remote repository. And here is the Commons Lang 3 library, and it's 3.3.2. And if you do your homework on this library, you'll realize that is the current version. So what you can do is click on that current version, and here it's going to give you the actual XML snippet that you need to include this dependency within your Maven project. So I'm simply going to copy that XML, and then we're going to head back to our POM file, and we're simply going to paste that within the dependencies section of our project. And now we'll save our pom.xml file. So with that dependency specified in our pom.xml file, we're going to head to our terminal, and within the terminal, we're going to execute a goal, and we're going to use the dependency plugin. And on the dependency plugin, we're going to execute the copy dependencies goal. And this will tell Maven to pull down the dependencies for our project and place them within our local repository. So here we see that Maven has pulled down a copy of Commons Lang, and we see it also has pulled down some other different files it needs. So we see a bunch of POMs coming down there. You'll see that it placed the Commons Lang library within our target directory, but we'll also see if we would head to our local repository. So a local repository sits on your machine, and basically it acts as a cache. So any dependencies that you pull down from a remote repository get cached within your local repository. Now you can also build local artifacts and install them into your local repository. So it's kind of a combination of those things. And it also holds a bunch of the plugins that we use within Maven. It's always within your username.m2. It's always within that directory unless you specify otherwise. I would recommend keeping that default. It's pretty common. So within that repository folder, here you're going to see a bunch of the different group IDs specified out. So for Commons Lang, it was org.apache.commons, and there we see Commons Lang 3, and then there was our version number, and there we see the actual jar file that we need. So we can see how that was pulled into our local repository. And what we can also do now, in order to get that dependency into Eclipse, is we can execute the Eclipse goal. Because if we look at our reference libraries, right now we do not have that library. So let's just rebuild that Eclipse project. And once we do that, we will see that we'll now have the commons lang.jar file included within our reference libraries. So I'm just going to refresh. There we see it's now available. So let's go over to our class. And within this class, we can use the stringUtils class, which is from our dependency, and call our isNumeric method. And we can pass in our string, and we'll take out that second return statement. And now we have used a dependency which we've pulled down from a remote repository within our application. We didn't need to go out and download that jar file. We just had to specify it within our pom.xml file within that dependencies section. This was an introduction to dependencies, and I hope you see some of the power that it brings to Maven and some of the convenience that is appealing to many developers. One of the great features about Maven's dependency management system is that it is capable of downloading transitive dependencies. A transitive dependency is simply a dependency of one of our dependencies. So for example, when using the Spring framework, there are other libraries that are leveraged by the Spring framework. And in order to use that framework, we must identify and include those libraries on our class path. So if we were manually using Spring, we would have to pull in all the Spring jars and then all of the other jars that it depends on. Under Maven, all of that work is performed for us using the dependency management system. Let's run through a demonstration to learn more about transitive dependencies. You'll notice within our More Maven Examples project, there is an app test class within the source test Java source folder. So we have a unit test, and you'll see that the creator of our archetype created a very simple unit test. We just have this test app method, which will be called, and it asserts that true is equal to true. So it's nothing very complicated, but you'll see that within the pom.xml file, that JUnit is listed as one of our dependencies. But you'll also notice that we're using version 3.8.1. The first thing I think is, well, that seems out of date to me. So if we go check JUnit's website, we see that the latest version is 4.12, and we can tell that we are out of date at this point. Let's go back into our POM file and just change our version to 4.1.2. And we will save our POM file, And now we're just going to head to the terminal and we're going to update our Eclipse project by running the Eclipse plugin with the Eclipse goal. So we see that Maven has built our Eclipse project and it was successful. So let's go and refresh our project. And now let's look at our reference libraries. Now you'll notice that we are now pulling down this hamcrest-core-1.3. And if I quickly switch it back to 3.8.1 and I save it and I run our Eclipse goal again, you'll notice that that library was not used for that previous version of Eclipse. We no longer see the Hamcrest jar. So if we switch back to 4.1.2, we'll notice we get that Hamcrest jar again. So the question is, where did that come from, and how did Maven know that JUnit needed the Hamcrest core jar? So if we head out to Maven Central, let's look at the JUnit dependency. So I'm just going to put in JUnit. There we see the latest version 4.1.2, and that's the one we're using. Let's drill down into that. And what's interesting is here you see the actual POM file for the JUnit project. And within there we see the group ID, the artifact ID. It sort of looks like a lot of the POMs that we've created. We see the organization, we see some licenses, developers, and then we're going to eventually get to where the JUnit project has specified its dependencies within the POM. There you see where we are including that hamcrest-core artifact. And that is a transitive dependency of one of our dependencies. So we know that JUnit has a dependency on Hamcrest, and then since we are leveraging JUnit as a dependency within our project and specifying that within our POM file, Maven is smart enough to consult JUnit's POM file and realize that we need that hamcrest-core-1.3.jar library in order for our application to properly run its unit tests. So you can really see the power of transitive dependencies. Now, what you didn't see is how many layers deep this can go, and there's an infinite level of dependencies deep this can go. So for example, if Hamcrest had its own dependencies, let's say it used commons collections, Maven would also be smart enough to consult Hamcrest's POM and go out and pull down common collections. So it's very useful when we are working with complex libraries, especially something like Spring. This is where I've really seen the benefit in my work. Spring has a large amount of dependencies, and using something like Maven, it makes it a lot more manageable. And I really think it has helped the framework gain adoption from the mainstream. So this is an introduction to transitive dependency management, and it's very beneficial to us as a developer because we are now out of the business of managing a bunch of versions, and we don't have to track down every last dependency that's out there. When we specify a dependency within a POM, Maven is responsible for resolving that dependency with one of its remote repositories. So for example, when we specify the commons lang artifact, Maven needs to have some place to retrieve that artifact for us, and that's done within the repository. A repository holds a collection of plugins and dependencies. Now, often these repositories are remote, so we access them through a protocol, something like HTTP or HTTPS, and we use that transport mechanism to obtain our dependencies. One of the questions you may have is how or where does the repository get specified? So how do we know to go out to, let's say, the Maven Central repository and pull down the commons lang artifact? Well, if we head to the terminal, we can execute the help effective POM goal. So we're using the help plugin and we're viewing the effective POM by executing the effective POM goal. And this is going to show us the effective POM for our More Maven Examples project. Let's maximize this window. And if we scroll up through the effective POM, you will come to a spot where you will notice the repositories that are listed. Here we are. You'll see that we are pointing at the central repository for Maven. So this is how Maven knows how to go out and grab our dependencies, and it knows where to go. Now, one of the things we can do is we can tell Maven about other remote repositories that it can use. To do this, we need to modify our settings.xml file. So I'm going to navigate to the directory where I have installed Maven. So I always put mine within the development software directory. And then here's our Maven install folder. And then you'll notice this conf folder, which will hold all of the configuration. So just double click the settings file and Maven will open up the settings file for all of your Maven installations. So for example, if somebody else was pointing at this installation, it would apply any changes I make to the settings file to their instance of Maven because it's essentially the same one. Now, you will also find a settings file within your M2 directory, so your local repository, and that settings file would just be specific to a user. I have Maven installed on my machine. Multiple accounts on this machine could point to the same Maven installation, and because I'm using the settings.xml file within the install conf directory, I am modifying the settings for every instance of Maven being used on this machine. So in order to specify a new remote repository, we need to navigate to the Profiles section. Here we see Profiles, we see the opening tag, and there's a bunch of comments explaining what we can do. And there's actually a example of using a repository there. So we're going to go ahead and put in the Spring remote repository. And this would allow us to download any of our artifacts directly from Spring. The first thing we need to do is specify the profile tag, and that just indicates we're making a new profile. Each profile should have an ID, so let's just call this Spring underscore remote. And the next thing that we'll do is we'll specify the repositories within that profile. We'll specify the individual repository, and that individual repository must have an ID. So we have an ID for our profile and then an ID for our individual repository within that profile. And we'll just call this our Spring underscore repository. And now what we need to specify is a URL for that repository. So this is going to point to the remote repository so that Maven knows where to find this new repository we're going to use. That is how to put it within the profile. And then what we need to do is we need to activate the profile, just like you see here in the comments. So I'm just going to add the active profiles tag, and then we need to put the singular active profile tag. And then within there, we need to specify the profile that we'd like to make active. And we can do that on one line. And we'll just point at our Spring underscore remote profile. And at this point, it is now included within our settings file. So if we were to return to our terminal at this point, and I'm just going to clear our terminal, and we're going to execute our help plugin and see our effective POM once again, we will now see that within the repositories, our Spring repository has been included. So let's just scroll up. There's our repositories tag, and there we see that we are able now to pull dependencies or artifacts from the Spring repository. So sometimes you will not be able to find the repository that you are after within Maven Central. Maybe it's a snapshot that didn't get included in Maven Central. Maybe you're trying to work with a specific version of Spring. Or maybe the artifact you're looking for simply isn't there, or it's something proprietary. For example, I know that Oracle has their own Maven repository, that you must authenticate with, and then you can access some of Oracle's libraries which are not published in the Maven Central Repository. So if your organization extensively uses Oracle, you may be interested in setting up Oracle as a remote repository. Just know that all you need to do is come into your settings.xml file, and you can specify a new profile that includes a new repository, and it will then become available to Maven so that Maven can search that repository for any dependencies. In this lesson, we're going to discuss Dependency Scope. We will see that Dependency Scope really tells us about when a dependency will be available during Maven's lifecycle. So let's run a few demonstrations to see Scope in action. The first thing I'm going to do is navigate to our dependency section within the More Maven Examples pom.xml file, and you'll see our two dependencies. We have the Commons Lang library, and we also have JUnit. Now, you'll notice that JUnit has this scope of test specified. Now, if we look at Commons Lang, we do not see a scope tag included within that dependency. Now, there is a default scope for every dependency, and that scope is compile. The compile dependency says that scopes are available on all class paths. So they're available when we build the application, and they're also available at runtime. When we have a dependency that is compile scoped, it will be available during the build, test, and run phases of our project. For example, if we navigate to our terminal and we execute the compile phase, and I'm actually going to specify the debug option by specifying -x before our phase, we will see that Maven will include Commons Lang 3-3.3.2.jar on our class path. So here we see the class path being specified, and then we see our jar being included. Now what you will notice is that our JUnit jar was not included. Well, why is that? If we return to our pom.xml file, we see that the JUnit dependency is test scoped. And when a dependency is test scoped, the dependency is not required for building or executing our project. It's mainly required for when we execute our unit tests. When we execute our unit test with something like JUnit or with something like testng, then we will see these dependencies on our class path. So if I were to return to our terminal, and I'll clear it out, and now I'm going to execute the test phase with the debug flag specified, we will notice when we find our class path, so I'm just going to scroll up and we should see our class path soon. Here we go. So here's our test class path, and we see that Commons Lang 3-3.3.2.jar was included, and that's because it's compile scope, so it's going to be available during all phases. But now we see that JUnit is available on our class path, and then we also see that the Hamcrest jar, which is a dependency of JUnit, is also available on our class path. And that's because the JUnit jar is test scoped, and that scope is propagating down to Hamcrest. Now, if I were to change the scope of JUnit, let's say I make it compile. Now, if we were to execute the Maven compile phase, we will see JUnit being placed upon the class path, as well as the Hamcrest jar, which is a transitive dependency. So here we see our class path once again. There we see Commons Lang, and here we see JUnit, and then below that we see Hamcrest. That is not preferable because we really don't need JUnit for compilation. So those are two dependency scopes, compile and test, and there are others available. So let's just take a look at what our options are. Here we see import. Import has to do with POMs, and you will really never use this phase It's very uncommon to have to use this phase, so we're not even going to go into discussing this. It's a little bit more advanced for our course where we're just introducing Maven. The next phase you'll see is provided. The provided scope is when you expect the dependency to be provided by something like the JDK or the container you're using. And what will happen when a dependency is scoped as provided is that the dependency will be available for the build and test phases, but then once we, let's say, deploy the web application or we jar up our application, those dependencies will not be available within that package because something else will be providing them. Usually it's something like our container. A great example for this is the servlet API. We may need that on our compile class path, but we really wouldn't have it when we package up our war and we want to run our web application because that's provided by our container, so Tomcat would give us that runtime environment, and we would just say that that dependency is provided. Our next option is runtime, and runtime is a scope that specifies a dependency is needed when we execute the system or when we test the application. However, a runtime dependency is not used for compilation. So for example, you may have something like the JDBC driver, which is going to implement the JDC API. And that JDBC driver, the implementation of it, isn't needed until you actually run the application, because compiling the code is not dependent upon the actual implementation, it's using that interface. We really only need that dependency for runtime. I really wouldn't use this one too much because it's not going to hurt to specify a runtime dependency as compile time. Not much is going to change there. And then our final scope is system. And I would really advise against using this scope because it's really going to make your Maven project very rigid. What the system scope is that it says that a dependency will be provided by the file system. It's basically placing your jars within an area on the file system, and then it goes out and finds those dependencies within that directory or that path that you specify. This can be a little bit dicey because let's say I have different paths specified on different machines. As soon as I would ship my POM out and try to use that on a different machine, it's going to break because we are really coupled to that directory structure. So I would not recommend using that scope. We'll just set the commons lang dependency back to compile, and that's going to wrap up our overview of Maven scopes. This is not something that really comes into play too much. You'll be using test most frequently, provided it's good for web applications. You'll encounter this some, but it's good to know, but it's not something that you'll be using often. In this lesson, we're going to take a look at conflicts between transitive dependencies and how we can resolve them. When we're building out our POM file, it's not uncommon to have a dependency that has transitive dependencies which conflict with another dependency's transitive dependencies. Let's take a look at what we're talking about, and we'll run through a simple demonstration to illustrate this concept. You'll see in our package explorer, we have Maven conflict example, Maven conflict example 2, and then more Maven examples. If we look at the POM for more Maven examples, we will see that it has a dependency on both the Maven conflict example project and the Maven conflict example 2 project or artifact. If we look at those projects' POMs, we'll see a dependency on commons lang. And for Maven conflict example, the version is 3.3.2, and for Maven conflict example 2, we have an earlier version of commons lang that is 3.0. When we compile the more Maven examples project by using the debug flag as well as the compile phase, what we'll see is that Maven is smart enough to notice those two dependencies conflict with each other. And when we look at our class path, you'll notice that only one of the jar files is included. So here is our class path elements being specified. We see that we get the Maven conflict example 1.0.jar. We get the commons lang 3.3.2 jar file, and then we get the Maven conflict example 2. What you'll notice is that Maven conflict example 2 had a transitive dependency on commons lang version 3.0. However, Maven was smart enough to realize that commons lang 3-3.2 was a more recent version of the jar file, and it resolved that conflict for us. So what if we absolutely had to have commons lang 3.0.jar included within our project? Well, Maven provides a mechanism that allows us to specify a dependency or an artifact that should be excluded, and that will cause the earlier version of commons lang to be included in the project. So all we need to do is go to the dependency that has a transitive dependency that we would like to exclude, and then we use the exclusions tag. And within the exclusions tag body, we can specify a single exclusion, and then we just need to specify the group ID, which is going to be org.apache.commons, and then we can specify a artifact ID, and that is going to be commons-lang3. Once our exclusion is in place, this will indicate to Maven that we no longer want to include the commons lang transitive dependency that is specified as a dependency of the Maven conflict example dependency. When we compile our application, we will now use the commons lang version 3.0, which is a dependency of the Maven conflict example 2 dependency. So I'm just going to save our POM file, and then I'm going to navigate back to our terminals window, and I'll just clear off the terminal. And now we're going to execute the compile phase one more time with the debug flag specified. And we'll just take a look at what makes it on our class path, and we should see that we're using that earlier version of commons lang. Here we see our class path elements once again, and now when we look down through, we see it puts our classes on the class path, as well as our first conflict jar, then it puts our second conflict jar on the class path, and then finally we see that we're using commons lang version 3.0. This is a way that you can manipulate and have a little bit more finer grained control over what transitive dependencies get used within your project. In this lesson, we will introduce our next chapter, which focuses on the Maven build lifecycle and plugins. Now, this is an important chapter because the build lifecycle and plugins are what we use to execute tasks against our Maven project. All of the actions that we take against our project, such as compile or such as clean, are all based upon this plugin framework that we use. And we know that these plugins are tied to the lifecycle of Maven. So let's take a look at some of our objectives for this chapter. The first thing we're going to do is take a look at the Maven lifecycle, and we are going to learn how it's constructed. And we will learn that there are these phases within the lifecycle. Next, we're going to move on and look at some of the more important phases, the phases that we will be commonly executing when we are working within a Maven project. Now, what we'll see as we look at these phases is that different plugins and their goals can be tied to a phase. So as we step through the lifecycle, a plugin can be executed depending upon the lifecycle phase we are in, if that relationship exists. We'll learn that the plugins can be invoked through the lifecycle, or we can explicitly invoke the plugins through the command line by calling the plugin and one of its goals. Now, after we see how to invoke the plugin via the command line, we're going to learn more about how to customize the behavior of the plugin. And we do that by providing some configuration. Now, this can come in two forms. One form is through command line arguments, and the other is by specifying some XML within our pom.xml file. Using these two approaches, we can modify how the plugins behave. That way they can better fit our projects. After we have discussed the out-of-the-box plugins and how they can be altered, then we're going to look at building our own plugin. The plugin we are going to build is very generic because it's not practical for me to really predict what type of plugins you will need. But what I can show you is how to build the framework of a custom plugin and how to configure that plugin to tie into the Maven lifecycle or so it can be invoked explicitly through the command line. So this chapter is going to lay a solid foundation for working with the build lifecycle and Maven plugins. And that is very important because as we move on, we're going to be using different plugins and customizing them in order to achieve specific objectives against our project. When working with Maven, one of the most important pieces in the Maven landscape is the build lifecycle. A lifecycle helps us when we build, test, or distribute an artifact. The lifecycle consists of a set of steps or stages that we go through as we build our artifact. Now, these stages or steps are referred to as phases. Within Maven, there are three built-in lifecycles, and that's the default lifecycle, the clean lifecycle, and the site lifecycle. And these individual lifecycles have their own particular phases. Now, these phases are very important because what happens when the lifecycle is executed is that a goal will bind to a particular phase. And we'll hear more about goals, but in general, a goal is pretty much the action that's going to be taken. You can almost think of a goal as a method. So it's going to perform some action against our project. The way the goals are executed is by being bound to a lifecycle phase. So it's very important that as we step through the different phases of the lifecycle, that we execute the appropriate goals. Let's run a quick demonstration to see a phase in action. Here we are at the command prompt for the More Maven Examples project, and what I can do is just type in the Maven application, and then I can execute a phase. I'm going to actually specify the clean phase, which is part of the clean lifecycle. What will happen is that the clean phase will be invoked, as well as every phase that precedes the clean phase within the clean lifecycle. So we can go ahead and execute that. We have ran this in the past, and we just see that our target directory, so that working directory we're using, gets cleaned up by Maven. Let's clear our console, and let's take a closer look at this. We can use the Help plugin to learn a little bit more about this phase. All I'm doing is using the describe goal on the Help plugin, and then I'm passing in a parameter to that plugin, which is the phase we would like to see. So I'm telling it we want to see the clean phase, and it's going to give us some information about the clean phase. What we see is we see the clean lifecycle. It specifies the different phases within that clean lifecycle. We see that there is a pre-clean phase. We also see below that there's a clean phase and then a post-clean phase. And what I'd like to draw your attention to is the clean phase. Here we see the plugin being bound to the clean phase, and then we also see the goal being bound to that clean phase. That's a good example of how we can look at a lifecycle and see what plugins are bound to what particular phases. One of the most important lifecycles is the default lifecycle. You'll probably be using this one the most. So let's hop in and take a look at this lifecycle. It has 23 phases, And this lifecycle is interesting because it will adjust itself depending upon the package that you specify within your pom.xml file. What will happen is since we have a jar packaging, the default lifecycle is smart enough to go out and grab particular plugins that are then bound to particular phases. However, if I were to modify the packaging XML element and give it a different value, let's say war, then our default lifecycle will get bound to different goals that are appropriate for that war packaging. Now we're going to leave it at jar and we're going to just run that last command. So we're going to describe the deploy phase, and this is that same command we issued for the clean lifecycle. Here we see within our console output that the deploy phase and the default lifecycle were described, and we see each of the phases within that default lifecycle. Here you'll notice that it even specifies it is a part of the lifecycle for the POM packaging jar. And it's describing each of the phases within that lifecycle, and then it's showing us what plugins are bound to those phases, just like last time. This is interesting. Here you see the resources plugin, and we're executing the resources goal. There we have the compiler plugin, and we are executing the compile goal. And there's our tests, and we see the tests being compiled, and then it looks like we're using the Surefire plugin to run them. And then eventually we run the jar plugin. And if this were a web application or a war packaging, we would not be running a jar plugin here, we'd be running a war plugin. And then finally we see the install plugin placing that artifact into our local repository. This is Maven's lifecycle, and this is what happens when we execute a particular phase via the command line. One thing you should know is that you can execute multiple phases via the command line. So for example, I can execute the clean phase and then the install phase. So two particular life cycles there, and we'll first see the clean occur, the clean plugin showed, and then you saw there was the test plugin, and then we're moving into the build, and we're installing our artifact into the repository. You can specify multiple phases on the command line. We took a look at the life cycle, and we saw how important it was because we are binding those actions or those goals from plugins to each phase. And that's one way that work is done, and it's how we build our artifacts from our projects. We know that a life cycle has phases. Now, the default life cycle has 23 phases. You won't use every one of these phases every time you use Maven. In this lesson, we're going to talk about some of the most important phases within the default lifecycle. Now, the default lifecycle is the one you'll be using most often. It is the one that is used to build a particular artifact. In this lesson, we're going to take a deeper dive into each one of these phases within the default lifecycle. Here we see the compile phase, the test compile phase, as well as the test, package, install, and deploy phase. We're going to learn what each one of these phases actually means. And that was a real sticking point for me when I was first learning Maven. Now, I understand compile and test, but there was a real discrepancy between what package, install, and deploy really meant. Once I had those things figured out, Maven became a lot more understandable. And that's what we're trying to do with this lesson. The first phase that we'll take a look at is the compile phase. And this is one of those obvious ones. We know that the compile phase is going to reach out and compile all of the source code within our source main Java directory, and it's going to turn our Java files into class files, which we can then execute via the JVM. The next phase is the test compile phase, and it's very similar to the compile phase, except this time we are compiling our unit tests. We will head to the source test Java source folder, grab those unit tests, and compile them. And then next we move into the test phase. And the test phase is when we are running our particular unit tests. So you may be using something like JUnit or TestNG, and this phase is going to kick off those tests. Now, by default, Maven will stop the build if any of the tests fails, but it can be configured to ignore failures or to skip unit tests altogether. So here you see a bit of XML that would be placed in a pom.xml file, and it is explaining how we can turn off our tests within Maven. Sometimes that is to our advantage. The next phase we'll take a look at is the package phase. The package phase is when we take our compiled code and we build that artifact that we're going to distribute. So we're talking about the jars, the ears, the wars, those items that we have that basically have our code packaged up that we can then deploy to a server or we can use within another code base. The package phase will create that artifact. Moving on, we then have the install phase. And the install phase is all about taking that artifact created within the package phase and placing it within our local repository. And that will allow other Maven projects to depend on that project, or we can reference that new artifact using the coordinates in a variety of other ways. And then finally, we have the deploy phase. Now, the deploy phase is really about working across environments. You can have a remote repository, let's say Maven Central, or maybe your organization has created their own remote repository that is shared by all of the developers within your organization or maybe your department. And when we deploy, we're basically pushing our artifact to that remote shared library that can be used for integration purposes amongst developers. I hope this lesson gave you a clear picture of the different phases that make up the default lifecycle. And we only looked at some of the most important phases, but I think you should now understand some of the phases you can run at the command line and what they will produce for you. In this lesson, we're going to take a look at goals and plugins. And these are two of the most important pieces of Maven. And that's because without these two pieces, nothing would ever happen to our projects. Goals perform tasks, and those tasks are ran against our project in order for something to happen. You could almost equivalent this to a method in a class. And plugins are comprised of a number of goals. So if a goal could be analogous to a method, a plugin would be analogous to a class. So a plugin has many goals. Within our More Maven Examples project, we're going to run a few demonstrations that really help us learn more about plugins. So I'm just going to maximize my console window. The first thing we're going to do is we're going to look at the syntax for executing a plugin. So the first thing we need to do is type mvn, so we are issuing a command against Maven, and then we type the name of the plugin. In our case, we're going to be working with the compiler plugin. And now a plugin is really just a prefix for the coordinates of a plugin. So it's going to have the group ID and the version, and that prefix instructs Maven where to find our goal. Now we put a colon and then we type the goal, and our goal is going to be compile. And we've seen this in action. So we see that our project now begins to compile and we've successfully executed that one goal. Now that we see the syntax, let's talk a little bit about where these plugins come from. Within our pom.xml file, we have not specified any plugins. So if I head over to the source, within this pom, there's no plugin specified. Where did that compiler come from? And we already know the answer to this, but let's just take a look. It's coming from SuperPom. So we're going to view the effective pom for our project. And once our effective pom prints out, we can scroll up and we'll see a few things going on. So the first thing I'd like to highlight, the plugin repositories. And plugin repositories are very similar to our regular dependency repositories. We just point to a URL, and here we're pointing to the Maven Central repository, and that's where we're getting a lot of our default plugins when working with Maven. Now, if we scroll down, you will see that there are core plugins already listed for Maven in the SuperPOM, and we're starting to get into those. Here we see a clean plugin, there's an install plugin, a Maven resources plugin, and let's scroll down until we find our compiler plugin. Here is the Maven compiler plugin, and we have a version for that plugin. And then we see some of the execution of that plugin. Here we see that plugin being bound to a phase, and then within that plugin definition, we also see the goals listed for that plugin. This is just a definition of the compiler plugin placed within SuperPOM, just to see where it's coming from. I'm going to clear our console, and now we're going to take a little bit more of a look at the compiler plugin, and we're going to use our help command to describe the compiler. This is a plugin in itself, so help is the plugin, describe is the goal, and we're going to provide a parameter, which is the plugin that we would like to see described. So there I'm describing the compiler plugin. And we'll see a few things with this. First, we see Maven going out to the central repo to get some other plugins it needed. But then we see that our compiler plugin has 3 goals. Up top, we see the name of the plugin, some description, the coordinates here, so the group ID, the artifact ID, and the version. Then we move into these goals. So we see that the compiler plugin has a compile goal, and we've already executed that. And then we see the compiler plugin also has a test compile goal, and that will actually bind to our test compile phase. The same plugin has goals that attach to different phases within the lifecycle. You also see that there is actually a help goal on the compiler plugin. That will allow us to learn a little bit more about the different goals within the plugin. So what I'm going to do is I'm going to execute the help goal on the compiler plugin. And we need to provide some arguments here. So the first thing I'm going to specify is that we want some details about this plugin and this goal. And then I'm going to specify the goal that I would like more information on. And I'm just going to use compile. And now this is going to have the compiler help goal list out some information about the compile goal. And if we scroll up, you can see it's quite a bit of information. And these are actually all the arguments that we can pass to the compiler. So here you see it starts to list the available parameters, and there's some compiler arguments that we can set. If we scroll down, we'll see some that are a little bit more familiar. So there you can specify the version of the compiler to use, whether you want the compiler to set the debug flag. We will also see that we can specify some of our memory. So if we would like the compiler to be allocated more or less memory when we run this goal. And then we will also see that we can specify where the source is located and where we would like to place the compiled files. While we were looking at the compiler plugin, this was just kind of a microcosm for the plugin and goal environment in Maven just in general. This is how all of the plugins and goals work within the entire tool. As we move on, we'll be taking a look at more of these plugins and these goals that we can use to perform different actions against our code base and our projects. And we'll be seeing more about how we can interact and supply parameters to these plugins via the command line and also via our XML configuration. When working with Maven, we can change the behavior of a plugin goal by specifying some arguments. Now, each plugin goal has some properties, and those properties will allow us to adjust how the goal behaves. If we would like to see the different properties on a particular plugin goal, we can use the help plugin. So I'm going to use the help plugin, and I will call the describe goal. And I'm actually going to specify a argument that allows us to tell the plugin which goal we would like to learn more about. So I'm going to use the compiler plugin and the compile goal. and then we specify another argument to say we would like the details. And when we do this, what you'll see is that we get a list of different properties we can set for this goal. And there are quite a few. There you see we can tell the compiler how much memory to use, how much initial memory to have. There's all sorts of different properties. We won't go into each one of these. Here you can specify the compiler version. We're going to mainly look at how we can set these properties. There's two different approaches to setting these properties, and we're going to explore each one. We're going to look at setting the verbose property, and if you'll notice below the verbose property, it has this user property, which is maven.compiler.verbose. We're just going to copy that because that is what we will use to set this property via the command line. So I'm going to clear our screen, and now we're going to execute the Maven compiler plugins compile goal, and we are going to set the verbose property via a command line argument. So I'm just going to paste our argument, and then we're just going to set it to true. So we're going to have equals true. And now when we compile our classes within our Maven project, we're going to get some additional output. Here we see the JDK actually telling us some things that it's doing. And we get a little bit more of a verbose output where we can possibly use this for debugging. Here we see where it's searching for class files on the path, and we see what it's finding. And it looks like a lot of those are just the actual Java libraries. But this can be helpful, and you'll notice that we were able to set that property via this command line goal. That's one way we can provide values or arguments for the different properties of a plugin goal. Now we're going to run one more demonstration, and in this demonstration we are actually going to use the pom.xml file to specify that property that we want to use. So we'll provide some arguments or values for particular properties via the pom file. The nice thing about specifying these properties within the pom file is that they will be applied when we invoke the plugin goal directly, or when the goal is invoked by a lifecycle phase. So this is a better way to capture the behavior that we would like our project build to perform. To get started, we're just going to head into the pom file, and we're going to add the build tag, and that build tag will contain a plugin management tag. And within the plugin management tag, we can then specify the plugins we would like to adjust. Then we provide our plugin information. And as always, we need to provide some of the coordinates for the plugin so it knows exactly what we would like to work with. So I'm just going to provide the group ID, the artifact ID, that's Maven compiler plugin, and then I'm going to specify the version, it's 3.2, and then what we can do is within this we can use the configuration tag. And if we use autocomplete within the body of the configuration tag, you will see many of the properties that were available when we described the compiler plugin with the help goal. There we see target, and we also see verbose, and we're just going to set verbose here, and we're going to set it to true. Now we have configured with our pom.xml file how to compile our source code within our project, and we're saying we'd like to use that verbose flag. Now, if I head back to the console window, I'm first going to execute a clean to delete our working files, so we will trigger another compile. If we do not clean, there will already be class files within the target directory, and the compile command will just say there's nothing to compile. So now that we've done the clean, we're just going to execute the compile phase. And what we'll see is that we're going to get that compiler debugging output once again. And the same thing would happen if we would execute the compiler plugin explicitly. So if I were to use compiler, compile, As long as I would perform the clean again, it would execute using that verbose flag as a trigger. This is a look at two approaches that we can use to specify different properties and arguments for our plugin goals. We can use this throughout the course to configure particular plugins to behave in a manner that would be against the default configuration, so we can really customize how these plugins behave. We know that Maven provides us with several plugins, such as the compiler or the test plugin, that perform operations against our code base. But sometimes there is not a plugin available for what we want to do. In this case, we would build a Maven custom plugin. And a Maven custom plugin is simply a plugin that you've developed for your own needs to meet some case you have. Now, this is usually not the norm, it's usually the exception. You want to make sure you look for available plugins prior to developing your own. But in this lesson, we're going to take a look at how we can build a simple custom plugin. So let's get started building our first Maven custom plugin. The first thing I'm going to do is I'm going to navigate to my Eclipse workspace. From within the Eclipse workspace, I am going to use a plugin, the Archetype plugin, to create a project for our custom plugin. So I'm going to use the Archetype plugin, and I'm going to call the create goal on the plugin, and then I need to provide some arguments. The first thing I need to provide is the group ID of the plugin that we're creating. So I'm just going to call this com.infiniteskills.maven, and then I need to provide the artifact ID of the plugin we're creating, and we'll just call this first-custom. Next, I need to provide the archetype artifact ID, and this is going to be Maven-archetype-mojo. This is the archetype we will use to create our project. And then we also need to provide the archetype group ID, and that is org.apache.maven.archetypes. Once we have entered this command, we can build our new project, and this will be the project for our custom plugin. We see that it is created. Now I'm going to list out all my directories, and I'm going to navigate into First Custom. Within First Custom, I'm going to execute the Eclipse goal and command. That way we can access this project from within Eclipse. Now I can import that project. I'll just go through the import dialog, find my working directory, locate First Custom, and hit OK. Then I'll click my Finish button, and we have now loaded our plugin project into Eclipse. If we investigate within this project, you see this MyMojo class, and this was generated by the archetype, and we see this class file that extends abstract mojo. Mojo is kind of the same as a goal, because here you see we're specifying that this mojo applies to the touch goal. So if we were to fire off the touch command, it would execute this goal on our plugin. And then we see that we define an execute method, and the execute method basically does the work. So this is what gets fired off when we execute our plugin. And this one is very simple. The one that's provided to us just creates a touch.txt file and then writes touch.txt to the file. So it's almost like a hello world. I'm going to close that file. There are plenty of things you can do within a custom Maven plugin. We're not going to go too heavy into that. I can't predict what you would like to do in this file. That part is really up to you to provide the implementation. I'm just showing you the framework. We'll close that file. And now what we're going to do is we're going to install this plugin to our local repository. So I'm just going to execute the install command, and we will see we're downloading some things from Maven Central, so there were some other things that we needed to install. And once it's finished, then our new plugin will be located in our local repository for our use. Okay, and it looks like it was successfully installed. What we're going to do is we're going to test out this plugin. In order to do that, we will need to navigate to our More Maven Examples project. So I went back to my workspace now to More Maven Examples, and now I'm going to clear my console. And what we can do is within our plugin project, you'll see it has its own POM file. And if we look at the source of that POM, you will notice that there are coordinates to this artifact. What we can do is take the group ID and specify the full coordinates to our plugin. So I'm going to paste our group ID, I'm going to go back and grab our artifact ID, and I'm just separating everything by a semicolon. And then I'm going to put the touch goal. This is just the long way of specifying this goal. By specifying the group ID, the artifact ID, and then the goal to Maven, we are going to be able to execute that touch goal against the More Maven Examples project. We see that it completed successfully, and now if we refresh our More Maven Examples project, we see that touch.txt was built into that project. So this could be some for output. Maybe we're counting lines of code. You can do all sorts of things with these plugins, but here we just outputted that simple txt file once we executed the plugin. So at this point, I'm just going to clear our console, and we're going to pause here. This is a longer lesson, it's a little bit more in depth, and we're just going to take a break and we'll pick this topic up when we continue in our next video. During the last video, we were able to create a custom plugin and we were able to execute that plugin. Now, it looked a little bit strange how we executed that plugin because we were specifying the exact coordinates to the plugin and the goal that we wanted to execute. Normally, when we execute a goal, we are able to use a plugin prefix as opposed to specifying out the group ID and the artifact ID. So what we're going to do in the remainder of this lesson is we're going to learn how to provide that more concise way of referencing our plugin and its goals. The first thing we're going to do is we are going to navigate to our pom.xml file for the first custom project, and that is our plugin project. Within that POM file, we are going to work within the build tag, and inside the build tag, we're going to put a plugin. So there I'm using the plugins tag and putting one plugin within it. And now we're going to use an existing plugin, and this is the Maven plugin. Not very descriptive, but what this plugin will allow us to do is it will allow us to specify a prefix for our plugin so we can reference it in that short way. So there I just specified the version of 2.3, and then there is a configuration element that we need to provide, and then finally within this configuration element is the goal prefix. We're just going to call this fcustom, and that's going to be our prefix for this plugin. Now with that in place, what we'll want to do is head back to our terminal, and we're going to head to the Eclipse workspace, and then we're going to navigate back into first custom, and we're going to install those changes to our local repository so that when we access that plugin, they're in place. Now I'm going to clear our terminal, and we're going to head to our More Maven Examples pom.xml file. This is the project that is using our plugin. And what we're going to do is head into this POM and once again work with the build element. And inside the build element, we are going to add our plugin. So here you can see the plugins tag specifying an individual plugin within there. And now we need to provide the coordinates of our plugin. So we're going to grab the coordinates, head back to our pom.xml file, and we got to remove this packaging because that is not applicable. We can now provide those coordinates so Maven knows which plugin we're referring to. The next thing we'll need to do is provide some executions. And every execution needs an ID, and this is just a way to identify the execution. So I'm just going to call this first custom compile. And now we need to provide the phase we would like to bind this execution to. And I'm just going to bind it to the compile phase. It doesn't really matter with this simple plugin. And then we need to specify the goals that we would like to execute for this phase. Remember, we spoke about how we bind plugins to the lifecycle. This is exactly how it's done. And now, one thing I'm noticing, there is the plural executions. We need to provide a singular execution. That's one thing about Maven. It seems like for these one-to-many relationships between tags, there's always the plural tag followed by a singular tag inside of it. I'll straighten our tags up a little bit better so we can read them. We have now set up our custom plugin within our target project that we want to use it within. And we have set up that prefix, so let's go ahead and run that plugin within our target project. So once again, change directory to the workspace, then change directory to the More Maven Examples project, and now we will use Maven, and we're going to specify our plugin prefix, and then our touch goal. With that in place, we see Maven start the build. You can see that it was able to execute our goal, and if I expand our project after refreshing it, so I just click on the project, hit F5, you will then see the touch.txt file show up, showing that our goal had executed successfully. Now, the next thing I'm going to do is I'm going to clean this project, and then when I refresh, we're going to see that the touch file goes away. And now I'm going to clear our screen, and I'm just going to execute the package goal for this project. And since we have tied into that compile phase, we will see that we're going to execute our plugin and our goal there. So let's refresh, and once again, we see at the bottom of the list, aside from some other things, there's our artifact, we also have the touch.txt file. That was something that counted lines of code or maybe gave a report on some code. It would be ran because we bound it to that phase we wanted it to execute. So here we bind it to the phase and we specify what goal we would like it to execute when that phase is executed. So we called our custom plugin in two different ways. We called it by specifying a goal explicitly, and we also called it by executing a phase that it was tied to. This is just an overview of custom plugins. You may not need to create these, but if you ever do, now you have that framework and an understanding of it so that you could develop your own. We understand what plugins are all about and how to configure them, but there's this group of core plugins out there that we use with Maven that handle about 90% of our usage. And this chapter is meant to teach you how to use those plugins and to familiarize you with them so that you understand when to use these different plugins. Now, as we walk through this chapter, we're going to reinforce how you can invoke plugins. We know that you can invoke them explicitly by declaring the plugin and a goal, and you can also invoke them using a phase. We're also going to look more at the configurations that go into different plugins. Those are our objectives for this chapter. But there's a few notes I'd like to go over prior to starting. We said we're going to hit on the 90% of the plugins that we use the most. The compiler plugin would obviously fall into that category. However, we used it so much within our last chapter as our examples that we're not going to cover it within this chapter. Also, we are only going to take a look at a subset of the plugins available for Maven. There are many other plugins out there that you can use. People can create their own plugins. There is a wide scope of plugins available for any need you may have that's out there. In this chapter, though, we're only going to cover the ones that we use the most. If we take a look at Maven's website, you will see a list of all of the available plugins, and they've divided them into several groups. So we have the core plugins, and we're going to be looking at the clean plugin, the deploy plugin, the Install plugin, and the Surefire plugin within that section. And then you see the Packaging Types plugins. We'll take a look at the War, and we'll also take a look at the Jar plugin. And then the reporting plugins that are available, we know that Maven can create all of these different types of reports for our project. We're just going to take a look at the Javadoc plugin within that section. And then there are these different tools that we can use within Maven. And one of the tools we'll be looking at is the Archetype plugin. Now, we will not address that in its own lesson, but you'll see that used in a variety of other lessons, and you'll understand how to use it by the time we're finished. And then finally, we're going to take a look at this IDE plugin, and that is the Eclipse plugin. So we'll see how that can help us build an Eclipse project from a Maven project. Now, as I mentioned, there are many other plugins out there, and they even mention it on the site here, outside the Maven land. Here you see different things available to you. There's a SQL plugin that will execute SQL scripts. Here we have some others. There's Clover, a code coverage report generator. There's Jetty, which is obviously very popular. And there's also a Tomcat plugin. So if you're building a web application, you can deploy to that Tomcat plugin. This is just an overview of what we'll be looking at within this chapter. This lesson focuses on one of the simplest yet most often used Maven plugins, and that is the Clean plugin. Let's take a look at what it does. We're sitting here on the command line within a Maven project, and we all know that I can create an artifact from this project. So there I'm executing the package phase, and we will see that several items are created by executing that phase. There we see we get a pom.test.jar, we have some reports going on, we have some of the statuses of the compiler plugin, so everything is built within that target directory. I'm going to first clear the console, and now we're going to talk about clean and what it does. Clean is very simple. It's just going to clear that target directory for you. It is used when you're starting over. Normally when you're performing a new build, clean is the first thing that will execute, or one of the first thing that executes. That way that target directory is clear, and when you place the compiled files or your archive out there, there's no clutter that is remaining from a previous build. Very simply, we can execute the clean plugin by executing the clean phase. So there's the Maven command and then the clean phase. And then what we'll see if we refresh that directory is that everything was deleted. Let's first package again so we get some content in there. Okay, so we see our contents back. We can also invoke the plugin explicitly, and the clean plugin only has one goal, and that's the clean goal. We very rarely configure this plugin, so it's not even worth going over any details there. And you can actually see in the output, it really explains very well what the clean plugin does. It's just deleting that target directory where all of your artifact files are going to be placed. In this lesson, we are going to learn how to use the Jar plugin. The Jar plugin is a core Maven plugin, and we use it to build a jar file from our current project. The Jar plugin also allows us to build a jar from our test classes. We're mainly going to focus on building a jar from our current project, though, for the purposes of this lesson. Using the Jar plugin is pretty simple. You can invoke it from the phase. So you can look at the package phase. You will see that we will create a jar when we run the package phase in Maven. So if I were to refresh our project, then we see we have this jar created. Now, we could also explicitly invoke the jar plugin by using the jar plugin and then the jar goal. And in the same case here, we will see that our jar file is then created. So I'm just going to clean our project, and now I'm going to clear our console. And we're going to take a look now at how we can specify some parameters when we create our jar files using the jar plugin. So we're going to explicitly call the jar goal on the jar plugin, and we're going to provide two parameters. The first is final name, and this is going to be the name of the jar file, and I'm just going to call it test. And then we can also specify that we would like to force the creation of a jar each time. So if nothing has changed, we may not create that jar file. But with this parameter, we are going to say create the jar file every time. Now, you may be wondering, where did I get these parameters that we can set for the jar plugin and the jar goal? Well, if you go to Maven's website, you will see that for the core jar plugin, there is a page and it lists all of the goals for the plugin. So there we can see the jar goal, and we're building a jar from the current project, and then the test jar goal, where we are building a jar from our test classes. If you'd like to learn more about the plugin, you can always come to this page, and it's going to provide you with a little bit more information. Now, if you click on a goal, it will dive down in, and here's where we can really see those different parameters. So here we can see where I have specified the final name, and it's going to be the name of the generated jar. And then I'm also specifying this force creation, and that's a Boolean, and it's saying we're going to build a new jar even if none of the components appear to have changed. You can always come in and see these different parameters that are available to you. Here's one that will exclude different files from being built into the jar. And then there's also this skip if empty. So if there is an empty directory, it won't get built into the jar. There's all sorts of parameters you can learn to use from this page. We won't go over each one in detail because it really is more of a see what you need approach and then go out and learn about it and then put it in place. I'll just touch on these two more heavily used ones. So let's go back and we'll now run this command. And what we're going to see is that we now have created a test jar. There we see our new jar was created. And because we have specified those different parameters, we get a different named jar and we force the creation of it. Now, you know that there is more than one way to set these different parameters. We can also set these parameters within our pom.xml file. What we can do is come into the plugin management section of our POM, and we add another plugin, and we'll need to specify the artifact ID, and that's going to be the Maven jar plugin. And then we just have to specify the version, and it's going to be 2.4. And then we just provide some configuration for our plugin. So here I can write the final name, and let's just put pom test since we are changing that name via this pom configuration. We also can specify force configuration, set that to true, and then we can also set that we would like to exclude a particular file or a group of files. We're going to use a pattern here, and this is an ant style pattern. The two asterisks mean basically a recursive wildcard through the different directories. And you can see I'm trying to exclude a class named excludeme.class. And if we look at our source, we see that there is a class named excludeme.java. So we're going to make excludeme.class, and that should not find its way into our jar. So what we can do is let's head to the terminal, and what I'm going to do now is specify a few commands. I'm going to chain them together. We're going to execute the clean phase, then we're going to execute the compile phase, and then we're going to execute the jar goal through the jar plugin. I'm just going to run those commands, and there we can see that we have built our new jar. And if I refresh, you can see that we get pom.test.jar. And now what I'm going to do is just go into the file system and into my workspace, and I'm just going to open up that jar file so you can see that we did in fact exclude that file. So that was in the more Maven examples. And then we have the jar within the target. There's pom.test.jar. And what we'll see is as we drill down in that we only received app.class and that we excluded exclude_me.class. In this lesson, we're going to discuss the Javadoc plugin. The Javadoc plugin allows you to create Javadocs for your project which describe the API. Now, this can be very important, especially if you are producing a library that other people work with, because you want to be able to give them that detailed information about the interface you are providing. If you navigate to the Maven website, within the list of available plugins, you will see there is a reporting plugin named Javadoc. And once we click that link, we see that the Javadoc plugin has 14 different goals. We are mainly going to focus on the Javadoc goal, and this is the most basic goal. It generates all of the Javadocs for a project. Now you'll see the other goals allow you to create Javadocs for a test project. You can jar up your Javadocs. You can jar up your test Javadocs. There's many options with the Javadoc plugin, but you'll mainly use the Javadoc goal. So we can just click on that and you'll see that within that goal, we have some parameters that we can provide. You can say whether or not to specify the author within the Javadocs. You can change the source directory it goes to. There are headers in here, there's footers. So there's all sorts of ways you can customize this Javadoc plugin. Let's head back to Eclipse and now let's run through a demonstration with the Javadoc plugin. The first thing we'll do is we're going to use Maven and then we're going to put in the plugin ID followed by the goal ID. And we are simply going to create our Javadocs using the Javadoc goal. And once this executes, you'll notice that within our project, we now have these Javadocs underneath the target directory. And you can go to the index.html file and you can open it with Eclipse's internal web browser. And here you can see the Javadocs were generated for our project. So let's look at some ways that we can customize this now. I'm just going to clear our console and now I'm going to add a header and I'm just going to put infinite skills in the header and I'm also going to add a footer. So just some simple customizations using the parameters provided by the goal. So once we execute this, we can now refresh our project. And if we visit the index.html page one more time with our web browser, you're going to notice now that we have this header and this footer on our Javadocs. There's all sorts of customizations you can perform with the Javadoc plugin and the Javadoc goal. Now, we were just looking at this plugin via the command line, so let's move on and look at it, how we can configure this plugin and this goal via the POM. To work with the Javadoc plugin within our pom.xml file, the first thing that we need to do is to add the plugins tag to the build section of our pom.xml. And within the plugins tag, we're going to declare a new plugin, and then we're going to provide the coordinates to the Maven Javadoc plugin. So it's Maven-Javadoc-plugin. Then we're going to specify our group ID, which is org.apache.maven.plugins. And then finally, we're going to specify our version, and that version is 2.10.1. You may be asking, why didn't we just move on and configure our plugin? Why did we have to specify it within this plugins element as opposed to just putting its configuration into the plugin management XML element? Well, the answer is that the Javadoc plugin is not declared within SuperPOM, so it's not mentioned. That means we have to declare we are using the plugin. Now, the compiler plugin is declared within SuperPOM, so we can just place our configurations within the plugin management section. The configurations within the plugin management section will be inherited by any child projects of this Maven project. Now we can perform our configuration of the plugin. So we'll just add a new plugin element underneath of our plugins element within the plugin management section. And then we'll just specify the artifact ID of our new Javadoc plugin we've added. And what we're going to do is we are actually going to first, let's set one of those earlier settings we had. So one was the footer, I believe. So this is the new footer. And now we're going to bind this plugin to the compile phase. So we use the executions tag and then the singular execution tag, and then we can specify a phase. So we'll bind it to the compile phase, and now we need to provide a goal. So once again, a plural goals tag, then a singular goal tag, and then the goal that you would like to perform. So I'm just going to specify the jar goal, and this will have all of our Javadocs placed within a jar file for the project. Now let's navigate back to our terminal and we'll test out this configuration. The first thing I'm going to do is clean our project, and you'll see that will delete all of the files within our target directory. Then I'm going to clear our console, and then I will execute the Maven compile phase. And we should see that we get a jar file containing all of our Javadocs. So let's refresh our project, and there we see that we have generated all of the Javadocs and placed them within a jar file. This would be good if every time we compiled, we recreated our Javadocs. That way we can include any changes. This lesson gave you a quick introduction to the Javadoc plugin and how you can configure the plugin within your pom.xml file. There's different ways you can change this plugin to suit your needs. In this lesson, we're going to learn about the install and the deploy plugins. These are two plugins that help us distribute the Maven artifacts that we have built. Let's first start off by talking about the install plugin. The install plugin simply takes the artifact that we have built and it installs it into our local repository. Once in the local repository, then our other Maven projects can depend upon that artifact. Now, it's very simple to execute the install plugin and the install goal. In normal goal plugin syntax, it would be executed in this manner. It doesn't make much sense because in order to install something, we always have to compile our project and then we need to package it. It's best to just call the install plugin using the Maven install phase. And you'll notice after we run this build, we will see that Maven tells us it's installing our Javadocs to the local repository, as well as installing more Maven examples 1.0.jar file, which is our artifact, to our local repository. So that's exactly what we wanted. The install plugin is very simple. We're just taking an artifact and placing it within our local Maven repository. Now let's move on to the deploy plugin. The deploy plugin is a little bit different. We talked about local repositories and remote repositories. Well, the deploy plugin is meant to take our artifact and deploy it to a remote repository. A lot of times an organization will create their own Maven repository that serves as the repository for the entire organization, and it is set up as a remote for each of the developers. That way they're all working in this shared repo. And then obviously there are things like Maven Central that are shared amongst many individuals, people working across all sorts of organizations and just casual developers. The deploy plugin and the deploy goal will ship out our artifact to one of those remote repositories. It's much like the install plugin where we want to execute it using a phase as opposed to referencing the plugin and then the colon and the goal. So let's just fire off the Maven command and then we will fire off the deploy phase. And you're going to see this fail, and that's because we have not set up anything that tells Maven where to actually send our artifact. So here you see that deployment failed repository element was not specified in the POM inside distribution management element. So there is some configuration that we need to put in place in order to deploy to a remote repository. What I have done is I have my own repository manager. Now, there are several repository managers out there, and basically they provide all of the administrative work on a remote repository. I have chosen to use Artifactory, and I have my own repository manager sitting out there, and it's remote. So we're going to deploy to this repository manager, and that is the setup we need to provide to Maven. So let's head into our pom.xml file, and we're going to specify the distribution management tag, and then within that tag, we specify a new repository. With this repository, we need to provide an ID. I'm just going to call it kbowersocks, and then we need to provide a name for this repository. And then we need to provide the URL. And this is obviously a very important piece because this tells Maven where to distribute the artifact. So I'm just putting in the URL to my Artifactory remote repository. And hopefully that is in place correctly. And what I can actually do is Artifactory provides this nice little browser, and here is the repository I'm trying to go to, and I'm just going to grab this snippet of XML just to make sure it's correct. There they actually provide you with the distribution management tag so that your configuration is always correct. I wanted to show you doing that by hand because you may choose a remote repository that doesn't provide you with that capability, so you need to know the URL for that repo. So with this in place, what we can do is I'm going to execute the deploy phase, and we'll watch to make sure our build is successful. Okay, we had build success. And here you can actually see that it was uploading some of the artifacts we generated to my Artifactory remote repository. All we needed to do that was provide a little bit of configuration, and that configuration was the distribution management tag, which showed where we would like to send that artifact. And then if we refresh my Artifactory browser, and I like to go into the simple browser for Artifactory, there we can see that we have this project that we've created being released to Artifactory. And if I were working in a team environment, somebody on my team could come out and access that artifact that I've placed out there. When building an application, it's best practice to follow test-driven development. Having unit tests in place helps us build more quality classes, and it lets us know that we haven't broke anything when we make a change. Within Maven, we have been provided with the Surefire plugin so that we can integrate test-driven development into our build process. In this lesson, we're going to take a look at the Surefire plugin, and we'll see how to execute it. And we will also learn how to configure the plugin to behave appropriately for a given scenario. Within our More Maven Examples project, we have one test class, and within that test class are two tests. The first test is the test app test, and it simply asserts that true is equal to true, so that's going to pass. And then our second test simply asserts that true is equal to false, so that's going to fail. Let's head to our terminal, and we'll use the Maven command to invoke the test phase. So you'll see that the test phase compiled all of our test classes, and then we got this little execution report once the JUnit tests were ran. So here is this test section within our console, and we see that it's indicating we ran two tests and one failed. It gives us a little bit of the stack trace there, and then it provides us with some more generic results. You'll also notice that our build has been noted as failed. So if we head over to our project, we can refresh it And here you'll see that we also had some reports generated for us. Now these look a lot like our console output, but it's showing us where the failure was, and then we can also get this XML version, which translates into a JUnit description within Eclipse. So Eclipse understands that syntax and it's able to display it to us. I'm just going to close that. Now let's take a look at what happens if we were going to try to install this artifact into our local repository. So once again, the Maven command and now the install phase, and we should be going through that build, and then it's going to take the artifact and deploy it to the local repository. Well, you see that failed. So anytime we have tests fail, here it says failed to execute goal, and then it says there are test failures. That just stops everything, and we don't put a copy of our artifact within our local repository at that point. The same thing would happen if we were trying to perform a deploy. So this prevents you from releasing code that has issues with it into some other environment. Now, we can provide some configuration to work around that. Let's say maybe we didn't care whether or not our tests failed, or maybe our tests are very expensive to run, so we didn't want to run all of our unit tests. We can use the Maven test.skip parameter, and if we set that to true, that's going to tell Maven that we do not want to execute all of our unit tests. Just bypass them. Don't even worry about it. It won't even compile them. Now you'll notice that I'm executing an install, and I've specified that it should skip our unit tests, and now we have successfully built our project, and we have installed it into our local repository. Now, if we still wanted to run our tests, but we just wanted to ignore the failures, we can also do that. But to show you that, I'm actually going to head into our pom.xml file, and I'm going to show you how to configure the plugin within the XML file. The Surefire plugin is included in SuperPom, so you can place this configuration within the plugin management section of your pom.xml file. So we just add a new plugin, and you can guess what's next. The artifact ID, Maven-Surefire-Plugin. Now we specify the group ID, and it's just org.apache.mavens.plugins. And then we should specify the version that we are using, and that's 2.18.1. And now the configuration for the plugin. And one note about the versions, and also the group ID and the artifact ID, I seemingly just pull those out of nowhere. Well, you can consult SuperPom to see what you're using. You can also go to Maven's website, and they'll have version numbers for each of these plugins. Those may change depending upon when you view this tutorial. So you may need to go out. It'll be on Maven's official website. They'll have all the plugins listed, and you can see the version numbers there. So you may have to adjust those depending on when you watch this video. Now we're just going to tell Maven to ignore the test failures by specifying this test failure ignore element, and we're just going to provide a value of true. And now what we should see is we can perform our installation without even providing any other command line parameters that are changing Maven's configuration or its behavior. So I'm going to execute the MVN install phase, and here we see we had build success. But if we look up at our test section, you'll also see that we ran 2 tests. One of them failed, so we handled the failure, but we still installed that artifact to our local repository. So this is the Maven Surefire plugin, great for test-driven development and running unit tests during your build. This lesson will teach us how to use the Eclipse plugin to turn an ordinary Maven project into an Eclipse project. The first thing that we need to do in order to perform our demonstration is to just have a basic Maven project. So I'm just going to use the Archetype generate plugin, and we're going to accept all of the defaults. So this will be relatively quick. So once it lists all the archetypes, we just hit enter to select the default. We'll choose 6. Now we got to provide a group ID, and I'm just going to use com.infiniteskills.maven. And then I'm going to use Eclipse Demo as the artifact ID. I'll make it a snapshot. We'll accept that packaging. and we'll accept the confirmation. Okay, so now if we look in this directory, we see that we have the Eclipse Demo. And if we look in this directory, you see that we have a pom.xml and a source file, but you'll notice we don't have that Eclipse packaging within that directory, so I cannot open that project in Eclipse right now. Well, the nice thing about the Maven Eclipse plugin is that we just have to run one command, and all of a sudden this project, which we just created, it's an ordinary, regular Maven project, is now available to be opened in Eclipse. So all you need to do is use the Maven command, the Eclipse plugin, and the Eclipse goal. Just hit enter, and in a few seconds, all of a sudden your project is converted, and now you can import it easily into Eclipse. So file, import, existing projects into workspace, and then find your project within the workspace. There's Eclipse Demo, and you'll notice immediately that Eclipse picks up this once Maven project as now an Eclipse project as well. You couldn't do that easily with just anything that you've pulled down. But if your project adheres to the Maven standard directory structure, you can execute that Eclipse goal against it, and then you can easily import it. Now, this is just the Eclipse plugin. There are other plugins out there for other IDEs. So if you do not use Eclipse regularly, you can go find the plugin that matches the IDE of your choice. Another capability of Maven is to package a web application. To package a web application, we can use the War plugin. Now, we haven't spoke much about how Maven interacts with web applications, but in this lesson, we're going to take a look at how to generate a web application and then how to package it using the War plugin. The first thing we need to do is we need to build a web application. To do that, we're going to use the Archetype plugin, and we're going to execute the generate goal. You'll notice the first thing the Archetype plugin asks us for is to apply a filter or select the number of an archetype we'd like to use. Well, we're going to filter to the Maven Archetype Web App plugin, and there you see that it is plugin number 1, so we can just choose number 1. And then at this point, it's going to ask us for the version we would like to use. Let's use the latest version, which is 1.0, so we'll select 5. And now we're going to have to assign a group ID. And like we've used for the entire course, we'll use com.infiniteskills.maven. And now we need to specify an artifact ID. So I'm going to use web-maven-example. It will ask us for a version. We can go with the default here, 1.0-snapshot. And then it's going to ask us for a package, and we can use com.infiniteskills.maven. Next, it will just ask us to confirm all of this information, so just supply a Y or hit enter. And now, if we were to look into our workspace within Maven, you will notice that we have the web Maven example. So let's just change directory to that project, and I'll clear our console. And now let's run the Eclipse plugin as well as the Eclipse goal on this project, and we can begin to import this project into Eclipse. So we'll just go to File, Import, then select Existing Projects into Workspace, and then we will see the Web Maven example within our workspace. Select it and then press OK, and then click the Finish button. And at this point, I'm going to clear our console. And now you'll notice that we have this web application. And the way I can tell that is because within the source main web app directory, there is the webinf folder and the web.xml folder. You will also notice that within the pom.xml file, if we look at our coordinates for this artifact, we see the group ID, the artifact ID, and then below it, we see the packaging has been switched to war. So this is going to change how Maven behaves when we package this artifact. So one of the things we can do is we can just head into the command line, and we'll use the Maven command, and then we're going to execute the package phase. And this is going to use the war plugin. Let's see if we can find it. There we see it calling upon the war plugin, and it's telling our application to be packaged, and it's saying it's assembling our application, and then here you see it is creating that war file for us. So let's take a look after we refresh our project within the target directory, and there we see our war file has been generated. We can also customize the behavior of the war plugin. If we head to our pom.xml file, we can enter the build section, and within a plugins tag which we can add the war plugin. So I'll specify the group ID, which is org.apache.maven.plugins, and then our artifact ID, which is maven-war-plugin, and then we'll provide a version ID, which will be 2.6. We can now enter any configurations that we would like. So within this configuration tag, we can pretty much look for whatever we would like to modify. These properties are all specified within the documentation. For example, here we can change the war name to, let's just go with Maven Web, and we'll actually want to remove this final name if we're going to override that property there. So here we're just telling it to use a different name for the war that it is building, and we can head back to our terminal and test out this configuration. And this time, let's call the plugin explicitly. So we'll use the war plugin and the war goal. And when we execute, we're going to see that it's going to pull down the war plugin. It's getting 2.6. And after we pulled down all of these different associated plugins, looks like it's a bunch of POM files there, we should get on to building our war file. Okay, so there we see we had build success. You can see it's building out that war file. I can test that within the package explorer. There we see the maven web.war file. We still see web-maven-example because we didn't clean our directory prior, but here you can see that it generated that war file using the name that we provided within the configuration. In this lesson, we're going to focus on how we can create and structure Maven projects. To do this, we're going to look at two features of Maven, that is the Archetype plugin and the Maven multi-module project. Using these two features, you will see that we can quickly generate a project, or we can structure a large project so that it's easier to manage. Let's take a look at our chapter objectives. The first objective is pretty simple. We want to take a look at these archetypes, and we want to learn how to build them, and we want to understand why they are beneficial to us. The main benefit of an archetype is that it provides us with some reusability. We can take a project template that has already been configured, and we can use that to quickly set up a new project. As we work throughout the chapter, you will see that we will build a project based upon a Spring template. And if you're aware of Spring, you know there's a lot of configuration, and we can do it fairly quickly with the Archetype plugin. We can set that project up. We'll also learn how to build our own custom archetypes, and this is very beneficial because sometimes you want to take a base project or a project template that you have structured and you want to encapsulate that and then be able to provide it to somebody else. And then that allows them to start off with the same structure that you have, and it can be used to apply a project template across an organization. We will learn how to build that archetype and put it in our local repository. Next, we'll switch gears and we'll look at Maven multi-module projects. A multi-module project allows us to take a large system or application that's divided into sub-projects, and Maven allows us to manage that project almost as if it's one project. You're just having different divisions amongst the modules within the project. So you have a parent project, and under that parent project are several modules that can all be managed at that parent level. This provides us some benefits as we work with these large projects because we can identify the dependencies between the projects and we can perform operations across the entire system as opposed to these single submodules. We will take a look at how to set up a multi-module project, and we'll run some different phases against the project so we can just see the type of operations we can perform against it. This chapter is designed to teach you how to get up and running with a Maven project and how to structure a project. These are a little bit more advanced techniques than just building a simple project at first. As you move on and the projects you work on become more advanced, you can use these more advanced Maven techniques to your benefit and as a tool. This lesson will focus on the power of archetypes. We have seen archetypes, and we know that we can create a simple Maven project using an archetype, or we can create a simple web project. But what we haven't seen is how powerful these archetypes can be when they are used as a template. When we talk about an archetype, the definition of an archetype is an original that has been imitated. It can also be defined as an original pattern or model from which all other things of the same kind are made. So this is all about templating. And while those basic Maven projects are very useful, they are not as useful as providing a template for something that has more configuration that is more elaborate. What we're going to take a look at is how we can configure a Spring project using an archetype. If you've ever worked with Spring, you know there are many XML files that must be put in place. We're going to take a look at a Spring data project and how simply we can set up a Spring data project using an archetype. The first thing we're going to do is we are going to use the archetype generate goal, and it's going to go and download that plugin, and eventually we will get, once again, a list of all archetypes. What we're going to look at is an archetype that I have actually generated and published to the Maven Central repository. This archetype sets up a Spring Data JPA project, and we're just going to put that project in place and show how easy it is to create a Spring project from an archetype. Now we are asked to filter our list of archetypes, and the archetype ID for the archetype that I have built is spring-data-basic. And you will notice that it will filter down to the com.cloudfoundry.tothought Spring Data Basic archetype. And this is a basic archetype for Spring Data, Hibernate, and MySQL. So here we are putting a persistence layer in place that's using an ORM. Now, if you've ever configured Hibernate to work with MySQL and Spring Data, you know there's quite a bit of configuration there. But with our archetype, you'll see how quickly we can use a project that is pre-configured for us. So I'm just going to select the first archetype in that list and the only archetype. And now you're going to see it's going to start looking at the POM of that archetype and pulling down all the jar files that we need. There I can see it's pulling down the Spring Data Basic POM. It's also pulling down the Spring Data Basic jar. And it's going to prompt us for a group ID. And once again, we'll use com.infiniteskills.maven. An artifact ID, we will go with Spring Basic Demo. And we'll just accept the defaults for the version, the package, and then the confirmation. There you can see that we have just generated this project. So I'll clear our console, and now I'm going to just take a look at what's in our workspace, and then I'm going to change directory to the Spring Basic Demo, and then within this directory I'm going to execute the Eclipse goal, so this should look very familiar. Now what you'll see though is that when we execute this Eclipse goal, we're going to start pulling in all of our dependencies that is included within the project. So here we go one more time, pulling in a bunch of POMs. We should start pulling jars at one point also. There you can see we're starting to pull different jars, and those are all the dependencies that Spring has. There I just saw Hibernate go through. There's Spring Web MVC, Spring Context, Spring Core. There's Hibernate's Entity Manager, Hibernate Core. There's our database. And finally, we have all of our libraries. And now we can import this project into Eclipse. So we'll just head into our workspace and we'll look for that project. There is Spring Basic Demo. We'll click OK and click Finish. And if we look at this project, we will see there is a repository test already set up for us. Here's an entity, a repository. Within the source main resources directory, we have our persistence.xml file for JPA. There is our application context for Spring. We also have a test application context if we'd like to run tests. Let's just run a quick test against the test context. So I will comment out the regular application context, switch to the test context, and here we can run this unit test. You'll see that we successfully set up and ran a test within a Spring Data JPA application in about 3 to 4 minutes. So that is really the power of archetypes. Here is a complex project configuration that we pulled down from the Maven Central repository, and essentially we are ready to run using this framework with very minimal configuration. Now, another benefit of this is you could create one of these archetypes for your organization, and that archetype can be shared by your developers, and that will ensure that everybody is working with the same initial setup when they build a project. So let's say you had a policy that each project needed to use an ORM and Spring Data. Well, you could generate this archetype and then guide all of your developers to pull this down when they start a new project. That will give you some consistency across your portfolio of applications. So that is one of the real powerful pieces of an archetype, reducing that initial setup cost and introducing some consistency to your development. In this lesson, we will learn to build our own Maven archetype. We will walk through step by step the process of creating our own custom archetype. And once we have a custom archetype, we can then share this template project with others in our organization and within our teams. So this is a great way to standardize that basic project setup that you may use in a portfolio of applications across your organization. To begin, we need a simple Maven project that we would like to turn into a template via an archetype. We're going to use the Maven Archetype plugin, and we're going to use the generate goal. We're all familiar with this. We're going to accept pretty much all of the defaults here. We're just looking for a simple project that we can turn into an archetype. So I'll just accept the default as well as the default version. We will use com.infiniteskills.maven as our group ID, and then I'm going to use first archetype template as our artifact ID, accept the default versioning, the default packaging, and now we've built this archetype. I'm going to list out all of the directories within our Eclipse workspace, and now I'm going to change directory to the first archetype template. I'll clear our console, and we're going to turn this into an Eclipse project so we can work with it in Eclipse. While that's happening, I'll begin the import process. So File, Import, and then Existing Projects from Workspace. We browse to our Eclipse workspace, and we select our first archetype template project, and then we click Finish. Now, what you'll see if we expand this project is that we have that basic Maven setup. And I just want to add a class that's just going to represent some customization. And this is just to distinguish our project as something a little bit different. Normally, this would be a lot of XML configuration and jar files when you're setting up one of these templates. But let's just imagine there's some complex setup in this class, and we want that to be included in every project our organization creates. Now, we're not going to even provide any implementation, but we just have that complex setup, and we want everybody to start out with that. Now, what we can do is we can build an archetype from this project. And once again, we're going to call upon the Archetype plugin. However, this time we're going to use the create from project goal. And what you'll see is that when this goal executes, it's going to output the actual archetype to our target directory. So I'm just going to refresh our Package Explorer, and you'll notice we can now expand the target directory. And within there, we see a generated sources folder, and nested within that folder is the archetype folder. And this is the root of that archetype we've created. If we expand some of these directories, you'll notice that at one point we actually have the template project that we will be providing. So there you see the complex setup class and the app class, and those will be wrote out as a template. You'll also notice that this includes a POM file, which will be put into the template. So if we were to have any dependencies within this POM, they would be included within the template project. Now, one thing you do notice within this POM is we have this expression language. And these are basically parameters that are going to be provided by the individual generating this archetype. Once the user specifies a group ID and artifact ID, those values will be populated within this POM file when the archetype is generated. Now, if we continue to look at the folder structure, you'll see this metainf maven and then this archetype-metadata.xml. This file is pretty much a manifest of all of the files included within this archetype. Now, this is generated for us, so there's not too much you usually have to do there. Sometimes you may have to fix a little problem here or there, but for the most part, it is generated for us. So I'm going to close those, and then I would like to also point out that our archetype itself, look at the directory we're sitting at here. We're sitting right within that archetype directory. There's another pom.xml file. And this really has the information we need to build an archetype. It has the Maven Archetype plugin, and then we see there's an extension specified, that it's archetype packaging. And then you'll notice that for the packaging, we actually point to that new type of packaging, which is Maven-Archetype. And this tells Maven when it begins the build of this archetype that it is an archetype. Just the same way a jar indicates a jar and a war indicates a war. It gives Maven some clues when we want to build or install this archetype. What we want to do now that we have created this archetype is we want to navigate to that archetype directory. So I'm changing directory into the target, into the generated sources directory, and then finally into my archetype directory. And once I'm in here, we will install this archetype into our local repository. And at that point, it will become available as an archetype that we can use as a template. So I'm just running the install phase. And there we see that we have successfully put the archetype into our local repository. Now that we have that archetype available, let's generate a new project from the archetype. I'm going to navigate back to my Eclipse workspace. So there I'm sitting within my workspace directory, and I'll clear my console. And now what we're going to do is we're going to run the Archetype plugin one more time. And this time we are going to base our project off of our first archetype template, Archetype. So we are going to use that archetype we just created as a template for this new project. So what I can do is I can filter to that archetype, and there you see the com.infiniteskills.maven first archetype template archetype. You'll notice that it's indicating that this is from our local repository, whereas some of the others, it's indicating it's from a remote repository. We have the one we want, so let's just select that only one. So we type in the number 1, and now we provide a group ID. And I'm just going to use a different group ID slightly here, just so you can see that it takes this value and uses it as a placeholder within our new project. So there's our template. I'm going to make this artifact ID simple template project, and we'll accept all the defaults from here on out. Now we're going to list everything within our working directory. I'm going to change to the simple template project directory, and I'm just going to pull this into Eclipse so we can view it. As that's working, I'll start the import process again. So there is the simple template project, and we pull that into Eclipse. And here we see that we have created a project based upon our archetype. So there's the complex setup.java file. And then if we look at our pom.xml file, we see that we used the values we provided. So there's com.infiniteskills.template. And that is a value we provided when generating the archetype. And then that placeholder got put into that pom.xml file. In this example, we walk step by step through how you can create your own custom archetype. This is great for creating a lot of standardization across your team or your organization. When we build complex applications or systems, not all of our code is contained in one project. Often, it is a common practice to separate your code out into different modules or different projects. And they have some independent piece of functionality that then makes up the whole system or the whole application. Maven supports building a multi-module project. For example, when building a web application, you may have the web layer, but you may also have a layer that services your API, and you may also just have a straight services layer. So it may be to your benefit to separate out those pieces of the application into different projects or different modules. Maven supports this by allowing us to specify some configuration within the pom.xml file that will indicate that there are additional modules to a project. If we look at our package explorer, you will notice that I have three different projects established. One is the Maven multi-module base project. Another is the Maven multi-module module project, and then there is the Maven multi-module module 2 project. Now, the Maven multi-module module projects follow the Maven structure. So you see the source main Java standard directory, source test Java. I just use the archetype to generate these simple projects. There's nothing within them. But what you'll see is the Maven multi-module base, which will act as the parent project within our configuration, only has the pom.xml file. And that's because it's just going to house our configuration for these groups of modules that work together. So if we take a look at that pom.xml file, there are a few modifications we need to make. This is the generic pom.xml file that you would get if you were to execute the Maven archetype generate goal. And what you'll see is that it has the jar packaging set. We need to correct that, and it needs to be set to pom. And this just simply specifies that our project is only going to have configuration. It won't actually have any source code. Now, the next thing we would need to do to make this a multi-module project is we would need to specify modules. So we will add the modules tab to our pom.xml file, and then we need to add the singular module tab to the pom.xml file, and then we need to point to the Maven multi-module module project and then the second module project. What we can do is, much like a lot of other configuration, we can specify a relative path. So we're telling it to jump back a directory to the workspace. So this is saying hop back to the Eclipse workspace, and now we can specify that multi-module module project. So there is our first project, and now let's specify our second. Okay, that is our configuration, and that's all the changes we need to make to create a multi-module project. Just remember that all of these projects are sitting within our Eclipse workspace, so they're sitting at that same level in the hierarchy, and our pom.xml file sits within our actual project directory, so we need to navigate back one directory in order to access these modules. Okay, so with this configuration in place, what you'll see is that we can now execute different Maven commands against the entire multi-module project. So for example, if I told all of my modules to compile, what you'll see is that when the compiler plugin kicks in, it will use what is known as the Reactor plugin. The Reactor plugin helps us work with multi-module projects, but we see that it compiled all three of our projects. And if I were to refresh the Package Explorer, I would see that we compiled the multi-module Module 1 and 2 projects. So that command, which was issued within the Maven multi-module base directory, actually hit the other two projects. And we can also do something like we can clean them both, and we'll see that that phase that we specified gets executed across all three projects. We can also do a clean and then an install, and we'll see that all three projects will then get installed to the local repository. This is a great way that you can work with those larger projects that have to be divided out into different modules or different projects. And it allows you to kind of logically group them together with this parent file and this pom.xml configuration. This chapter will focus on a number of additional Maven features that really fall outside of any major category. Now, all of these features are still very helpful and important to know when working with the tool. We're just going to look at them separately as we work through this chapter. The first thing we're going to take a look at is how we can deploy to a web application server. We're going to install a Tomcat server, and then we're going to use a plugin to take a WAR file and deploy it to that Tomcat servlet container. Now, this can be very important because if you're working on web applications, you know that you need to be able to release your application or deploy your application for testing. Next, we'll take a look at encrypting the credentials we may use to log into a repository or a server. We have to put usernames and passwords within our configuration files. Well, it's not good to have those credentials in plain text. We know there are definitely security vulnerabilities that are created when we have plain text credentials. Using Maven, we can encrypt those credentials so that an attacker would not be able to use them if the system we're working on were compromised. Next, we'll take a look at the properties that we place within our configuration files. You will see how we can use dynamic properties, which can have values that come from our underlying operating system, from other places within our POM, or that can be just specified as a property within the configuration file. And having these configuration parameters be dynamic provides us with a little bit more flexibility within our configuration files, and it also makes them a little bit more manageable. And then finally in this chapter, we're just going to look at some additional ways that you can get help with Maven or that you can debug Maven. It's often important to know where to look when you have a problem or when you need to achieve something. So we'll just show you the different help features available within the tool and some of the additional debugging that it can provide. There's a lot of verbosity within the debugger, and we can turn that up, down, or off if we would like. This will be a chapter that just looks at some general features of the tool that can help you in your development. When working with a web application, we need somewhere to deploy that web application to. In this lesson, we're going to download the Apache Tomcat servlet container, and we're going to install it so that we can run demonstrations using Maven that interact with an application server. Now, Tomcat is not a full-blown J2EE application server. It is a servlet container, so it's a reduced set of functionality. But it still allows us to deploy applications or deploy our WAR files to a server. And that's what we're looking for, that interaction between Maven and some other repository. To begin, we're going to go to the Apache website, and it's tomcat.apache.org. And once at the website, just click on the Tomcat 8 download link, and then you can scroll down and you'll want to download a binary distribution, and you can just click on the zip file link. It will prompt you to download this zip file. Now, I have already downloaded the zip file, so you don't have to watch it download on my machine, and I've placed it on my desktop. All you need to do to install this servlet container is right-click on that zip file, and then extract the files to a directory. So here I've put them into the Apache-Tomcat-8.0-2.0 directory, and I'm actually going to cut that directory and I'm going to place it within my development software directory, just a place that I like to keep different tools that I use. Here you see we have the Apache Tomcat folder now within my software folder. One of the most important things to do is to configure Tomcat to have a user. So for example, if I go into the bin directory, I'm going to have all these tools that I can use to manage Tomcat. And I can start Tomcat, and you'll see this console window pop up, and there we see the server is started. Now, if I navigate to my browser, I can access Tomcat by typing localhost colon 8080. So 8080 is the HTTP port. Then we will hit the Tomcat webpage. So this is being hosted by our Tomcat server. And you can go into the manager app and it's going to prompt you for a username and password. And we need to establish that. So what we can do, I'm just going to cancel, and it actually gives us the instructions here. It says we can add this role name tag and this username tag to our Tomcat users.xml file within the conf directory. So that's exactly what we're going to do. We're going to navigate back to the conf directory, and then we are going to edit the Tomcat users.xml file. I'll just open that in Notepad. There's not too much we need to do here. And now let's add the roles. So the first role is the manager GUI. And so we just add that role tag. We add that attribute for the role name. And now we need to add a user tag that's going to use that role. And the user is going to be Tomcat. And the password for the user will be secret with a 3 as the first E. And then we're going to specify the roles attribute, and we're going to give it a value of manager GUI. Okay, so just double check. Role name is equal to manager GUI. And then our username is equal to Tomcat, and our password is secret. And then we give the manager GUI role to that user. So with that modification in place, I'm going to go back to the bin directory, and this is how we start and stop Tomcat. Here you'll see the shutdown.bat script, and that just shut down my Tomcat servlet container. And now I'm going to start Tomcat one more time. And there we see the servlet started up. We did have a little error there. Let's see what that is. It's complaining about our user tag, so we just got to change that. There was no closing tag there. So just make sure when you specify this user tag that you put the self-terminating end tag at the end. So let's shut it down and then start it up one more time. Okay, and this time we had a clean start, and we can head back to our browser and hit the website one more time, and now hit the manager app, provide our credentials, and now we're in the Tomcat Web Application Manager. So if you are able to access this Web Application Manager, that is all of the configuration that you will need for a course. Now with Tomcat installed, we can run through some of our demonstrations that do a little bit more integration with an outside repository. When building web applications, it's important to be able to deploy the application to the server. Deploying the application allows us to test the application, or it allows us to release the application to one of our environments. In this lesson, we're going to learn to use the Maven Tomcat plugin to deploy a web application to a Tomcat servlet container. Now, on the left side of your screen, you'll notice that we have a project in the Package Explorer, and the project's name is my-web app. And this is a Maven web application that I've built using the Archetype plugin, and it's very simple. It just has one JSP that we're looking to deploy. So we will build this WAR file and deploy it to the Tomcat servlet container. Now, prior to doing this, we need to be sure that we have a user on our Tomcat servlet container. So I'm just going to go to my software directory, into the Tomcat directory, and look at the configuration directory. and then open this tomcat-users.xml file within Eclipse. You'll notice that at the bottom of this XML file, there is a role specified as the manager GUI, and then a username for a particular user that is Tomcat, and then we see a password secret with a 3 for the first E, and then the role of manager GUI assigned to this user. So those are the credentials we will be using to log into Tomcat. The first thing we're going to do is we're going to set up that server within our settings.xml file for Maven. So I'm going to navigate back to my software directory, into my Apache Maven directory, once again into the conf file, and I'm going to open the settings.xml file. Within this file, I'm going to add a server. So looking through the file, we will see that there is already a servers tag. There is the end tag for it. There is the start tag. So within here, we're going to specify a new server. And the server will need an ID, and I'm going to give the server an ID of Tomcat server. And then I need to specify a username. And if you remember, our username was Tomcat. And now I need to provide a password. And if you remember, our password was secret with a 3 for the first E. And with that in place, we have now defined our server within our Maven configuration. So I'm just going to save that file. And now we are going to navigate to the pom.xml file for our web application. Within this pom.xml file, we need to add the Maven Tomcat plugin. So the first thing we'll do is add the plugins tag. And within the plugins tag, we will define a single plugin. And we need to provide the coordinates for our plugin. So the group ID will be org.apache.tomcat.maven. And the artifact ID will be Tomcat 7-Maven-plugin. Now, obviously, that name is tied to a version, so if you're watching this at a later date, you may be using a different plugin, so you would want to go out to Maven Central and do some searching to find the plugin. The current version is 2.2, and now we're going to provide some configuration for this plugin. And the first thing we're going to tell it is the URL of the manager GUI we would like to use. We're going to specify localhost port 8080, and then we're going to use that manager directory and then text. And that is where we will interact with the application server to deploy our WAR file. And now we need to specify the server itself. So this is that ID that we specified within our settings.xml file. So at this point, I'm going to navigate to our terminals because we have all of our configuration in place. And now we will attempt to deploy our WAR to the Tomcat servlet container. To deploy the WAR file, we need to use the Maven command, and then we're going to use the Tomcat 7 plugin, and we're going to execute the deploy goal. So I will just enter that command, and then we will see that Maven will begin to build our WAR file, and then it's going to deploy our web application. And we see that it's deploying the WAR file to this location. So there's our context route, and you can see it actually used the artifact ID as the context route. So let's head to a web browser, and now we're going to hit our URL, and we can see we hit our web application. So we were able to deploy the WAR file using Maven and the Apache Tomcat plugin. When using Maven to build our projects, there are several times it must go out and connect to a remote server or some remote repository that requires authentication. So for example, we have the My Web App, and that My Web App runs out on a Tomcat server as we see here. Well, when we connect to that Tomcat server, we obviously have to provide some credentials. So if we look at our Tomcat users file, we see the credentials for the server, and in order to specify those credentials, we place an entry into our settings.xml file. So if we open that file up, we see the credentials that match the Tomcat server. Now, this doesn't have to be a Tomcat server. It can be any other remote machine you're trying to connect to. But one huge problem here, and this is a huge problem, is that this password we see is in plain text. This is a hacker's dream because they can then breach your system and then go on to breach probably more valuable systems that you're connecting to and deploying your applications to. And the next thing you know, millions of credit card numbers or somebody's social security card number is all over the web and being sold. We don't want that, so we need to protect our passwords. And Maven provides a great way for us to do that. In this lesson, we're going to learn how to encrypt our passwords within our Maven configuration files. In order to begin encryption, we need to create a master password. And the way we do that is we head to our terminal and we use the Maven command, and then we provide the emp parameter, and then we need to provide the password we would like to use as our master password. I'm just going to use test, and once we issue this command, you'll see that we now get this encrypted password. So just copy that password, and then right click, so hit copy. And now we're going to create a new file that's going to provide a lot of our security configuration. We're going to head into our Maven directory. Mine is within my user profile at .m2, so this is our local repository. And within this local repository, we need to create a new file. The name of this file will be settings-security, and it's an XML file. So we'll create that file, and now we're going to head back into Eclipse, and we're just going to simply open that file up. So navigate to my user profile into my local repository and open the settings-security.xml file. Now, within this file, we need to add a root tab of settings security. And then within that tab, we need to add a master tag, and we can then paste in our encrypted master password. Okay, so we have that in place. And now what we need to do is we need to encrypt the password for our Tomcat server. So we use Maven, and then we're going to provide the -ep parameter, and now we provide the password we would like to encrypt. So in our case, it's our Tomcat password, which is secret with the first E as a 3, and we can now encrypt that password when we issue the command. Once again, we copy this new password, and now we head to our settings.xml file where we provide the credentials for our server. And I'm simply going to paste those credentials, and we'll save our settings.xml file. Now we're going to learn a new Tomcat command here. So I have that application deployed. So first I'm going to undeploy it. And first this will actually test our credentials because we need to log in to undeploy. So I already know our credentials work because we need to have the credentials right to undeploy, but we will just run through another deploy just to verify those credentials one more time. So here we see that Tomcat is running through the plugin, and it has now deployed our web app file, and we can go into the browser. Need to copy that, and now we can go back to the browser, paste the URL, and we can see one more time that our application was deployed. So we learned how to protect our secrets, our credentials, and that makes our applications and our systems more secure. Believe me, at this point in time, all of your employers are very concerned about that. It's becoming the #1 issue. It's very important to know how to encrypt those credentials so they're not sitting there in plain text waiting for somebody to steal. Within the configuration in our pom.xml files, Maven allows us to specify properties that can be used to provide configuration values. Now, these properties use an expression-like script, and they allow us to make our configurations more dynamic, and we can use these properties to control configurations across multiple projects or submodules within a multi-module project. Maven provides us with several types of properties we can pull into our configuration files. These are project properties, environment properties, Java properties, and then custom defined properties that we create as the configurer. In this lesson, we're going to run through several demonstrations that illustrate how to use these properties. Within our My Web App project, which is a Maven web application, we are going to provide some configuration parameters within our pom.xml file. The first thing we're going to do is we see this final name, and that's going to dictate what the name of the war file is for this web project. We're just going to use the expression language, so it's a $sign and then two curly braces, closing and opening. And we're just going to specify the project artifact ID. So here we are using one of the project properties, and we can pretty much use any property within our project. So you could use like the group ID here, you could use the version, the name, but we're just putting the artifact ID here. And now we're going to head over to our terminal, and we are going to execute the package phase. And when we execute that package phase, we're going to see that we'll build a war file that has our artifact ID as the name of our war file. Within this final name tag, we can also illustrate the use of another property, and this is the Java property. So anything that we specify for the Java system configuration, we can use within the Maven POM file. This really makes no sense, but I'm just going to put the Java version as a appendix to our war file name. So we can head back to the console and we can run our package command once again. And this time we're going to see we will create another war file that has the Java version appended to the war file name. So I'm going to clean all of our war files up that we just created. We'll clear our console. And now we can move on to our next demonstration. So we're going to head back to the pom.xml file, and now we're going to use an environment variable within our configuration. For the description, I'm just going to use the path as one of our environment variables. So here I will print the path as the description of our web application. Now, once again, this really doesn't make any sense, but it's just a demonstration of using this parameter. Now, if we were to execute the site lifecycle and phase against our application, we will see that once our site is built, that the description will actually be our system's path. So here is the site, and then we can go into that HTML file. We'll open it with a web browser, and here you can see where the description would be. We are actually showing our path. You can use all of your environment variables within your pom.xml configuration. Okay, so I'm going to clear our console, and now we'll run through our final demonstration. This is the demonstration that's going to show you how to use a custom property within your configuration files. So there is the properties tag. We just add that properties tag within the pom.xml file, and then you can specify a custom tag, and the tag is the name of your property. So I'm going to go with Tomcat URL, and what I'm going to do now is I'm going to grab this URL that is configured for a Tomcat server, and we'll just turn that into a property. So once again, to reference it, I just use the expression language and put in Tomcat URL, and now I will take that value and paste it within our tag. So with this custom property in place and our Tomcat server still configured, we can head to the Terminals tab and we can execute the Tomcat 7 redeploy goal. And once we execute this goal, it will use that property that we provided to determine the URL to deploy our war file to. There we see that we successfully deployed our war file, and that was using that custom property that we defined within our pom.xml file. This lesson taught you how to use several different types of properties to make your configuration files a little bit more dynamic. A common pattern you see here is specifying a version. So for example, Spring includes many libraries, and what you'll see a lot of people do is create a custom Spring version property, and then they will use that Spring version property within each of their Spring dependencies. That way, they can switch all of the versions for their Spring libraries at once. So sometimes you can implement that strategy to use properties to your advantage. When working with any tool or piece of software, you may encounter a time when you're not sure how to proceed or what a particular action is that you must have to take. In these times, we often turn to help documentation, and it can guide us about the different parameters or options within a given command, or it can tell us what a command does. So anytime we're lost, we can turn to the help documentation. Maven provides help documentation, which we can access via the command line. There are several forms of the help documentation that we'll see. The first that we're going to look at is by simply using the Maven command and then providing the help option, so it's just dash help. And what this will do, it will list all of the options that we can specify for the Maven command. So you'll see quite a few here. Here's one that will encrypt the master password, encrypt a regular password. You can see that we can tell Maven to fail at certain times. There is the help option itself. We can specify where our log files will go. Here is the non-recursive option. So if we are working in a multi-module project, we can tell Maven not to recurse down into the sub-projects when we execute a goal or phase. There's also an offline mode in case you do not have connectivity. There's just a great deal of options here. Here's the version option. This can be helpful. So just type mvn-v and it's going to show your version information. And this is great for figuring out your Maven home. It will show you where it's installed. So if you ever have a question about that or you're working on a machine that you're not familiar with, you can always find out where Maven is installed. So let's clear our console and we're going to take a look at another form of help. Almost all of the plugins define a help goal. So here I'm issuing the Maven command, I'm specifying the compiler plugin, then a colon, and then our help goal. And this will tell me more about this particular plugin and the different goals that are available on it. We always have this help system in place that we can use to gain more information about Maven itself or the plugins that we're working with. Well, sometimes we need to get more information about our build. So what we can do is we can specify different levels of logging when we execute some for goal or phase against our application. Here on the left, we have our My Web App application, and we're just going to compile this project, and we're just going to specify different flags which will determine the verbosity of the log files. So for example, Maven-Q compile. The -Q option will tell Maven that we only want to print messages if there's an error or a problem. This can really tidy up the output. So there our compile just occurred. We can take a look and we see our my-webapp.war was created, but we didn't get any output because we specified that -Q flag. So for example, if I now perform a clean with -Q, we're just going to get the command prompt and you really won't get any confirmation or any details. So if you don't like having a cluttered console, that is one option. Now, another option is if we would like to receive more information. So let's say something's going wrong and we can't figure out why. Then you can specify the -X option, and this will print quite a bit of debugging output to the console, and it's primarily used when you're trying to diagnose a problem. It's definitely very useful. It's helped me in the past. So let's just run compile with the -X option. And you'll notice right off the bat, it's going to tell us like our operating system. There, it already printed out the version information. You can tell that we are getting quite a bit more output running this way. So it looks like that is my entire property that is being used there. Yeah, it's actually specifying the path that Java is using, it looks like, to perform the compile. So if there were an error with this build, you could get into the details to determine what is causing that error. That is quite a bit of console output just for that simple compile. But once again, it can be very helpful. So the -Q and -E options allow us to receive more or less output from Maven in our console or in our logs. So they're very helpful to kind of tailor that output. There is a -E option, which is primarily used if you're working on developing Maven, so actually building features into Maven, or if you're reporting any bugs. It's really not worth our time to demo the -e flag, but just be aware it's available in case you really dive into the tool and begin working with it at a very advanced level. In this lesson, we learn some different ways that we can get some help if we run into a situation where we may not know what to do, and we also learn some techniques for debugging any issues we may encounter when using Maven. In this chapter, we will focus on the Maven to Eclipse plugin. We know that Eclipse is a popular Java IDE. It's what we're using for this course. And the Maven to Eclipse plugin allows us to interact with Maven via our Eclipse IDE. Instead of working with the command line, as we have done for the majority of this course, we will now be able to interact with Maven through a graphical user interface provided by this plugin within the Eclipse IDE. Some of the things it allows us to do within Eclipse is to launch a Maven build. We can also use the M2E plugin to manage dependencies. You'll see that it's a little bit easier when using the plugin as opposed to when using the command line. So we're going to see a lot of great features that really support how we work with Maven. Now, one thing I'll note is that the M2E plugin does not cover 100% of our Maven use cases. There are some times when you will need to edit your POM file just because you simply can't accomplish what you would like using the M2E Eclipse integration. Let's take a look at some of our objectives for this chapter. The first is to learn how to create a Maven application or project using the M2E plugin. You will see that we can build a Maven project very similar to using the archetype generate goal, and it's going to develop that standard directory layout for us. And we will learn how to use a graphical user interface dialog that will allow us to build that Maven project very quickly. Next, we're going to look at dependency management using the plugin. This is really the strongest selling point of the plugin and the strongest selling point of Maven. This is actually where most people start using Maven. They will be using the M2E plugin and they will be using it for dependency management, and it really changes how you develop. We will no longer need to go out and search the web to find the coordinates of our dependencies. We more search for our dependencies right within our IDE. So that saves us a little bit of time and makes it a lot more manageable. Next, we will see how we can execute different phases and goals. So we're going to be kicking off those different builds, and we're going to be executing particular pieces of a build, and we can do that all within the M2E plugin. It's right there in the IDE available for us, and we're not navigating to the command line in order to tell Maven to perform some task or action. And then the final thing that we will do is we will look at how we can import Maven plugins through the M2E Eclipse plugin. We know that when working with Maven, there are times when the standard plugins we have just don't cut it, and we want to go out and grab some other plugin that's going to perform some great task for us, or it's going to give us some benefit, and we have to provide the coordinates for that plugin. Well, the M2E Eclipse plugin provides a little bit easier of an interface to include those plugins. I think you really catch on to the M2E plugin. It's a very handy feature within Eclipse. And the nice thing is if you download the Eclipse for Java EE developers, any of the recent versions of Eclipse will have this plugin already integrated into that download, and there's no installation. You see this plugin being used a lot more heavily now that is actually bundled with Eclipse, and it is a great time saver, especially for those of you who might not like working with the command line. In this lesson, we'll get our first experience with the M2E plugin by creating a new Maven project using the plugin. Before we begin, I'm just going to show you a little bit about the M2E plugin. If you are using the Eclipse Java EE for web developers version, you will see that the M2E plugin is already included within your Eclipse distribution. So I just went to Help and then clicked on About, and at the end here, we can see this last plugin is the M2E plugin. And if we click on it, we get a little bit more information about it. We see that it is the Maven integration for Eclipse. And that's exactly what we want. That will allow us to integrate Maven inside our Eclipse IDE. How do we start working with Maven inside of Eclipse? Well, the first thing we can do is create a new Maven project. So I just hit Control N, and that brings up my new dialog, and then I can just type Maven project. I'll select that project, and at this screen, you'll want to select Create a Simple Project. We're just setting up a basic Maven project, and we're not relying upon any archetype to provide us with a template for our project. You'll also notice under the Advanced section that we can specify profiles. However, we're not going to specify any profiles for this new project. We're just creating a simple project. Now, all of this should look familiar. It's asking you for a group ID, an artifact ID, a version, the packaging, a name, and a description. For the group ID, we're just going to go with com.infiniteskills.maven. And for the artifact ID, we're going to go with m2e-demo. We can specify the name as m2e-demo, and we can also provide a description. You'll notice we also have an area where we can specify a parent project. If you had another Maven project already installed within your local repository, you could then reference its coordinates, and the M2E plugin would include this as a parent within the pom.xml file it's going to generate. Once we have provided our coordinates for our project, we just hit Finish, and you will see that the M2E plugin will begin to generate our project. And here it placed that project within the Package Explorer. And we see that the project adheres to the Maven standard directory layout, and it also includes this pom.xml file. Now, when we double-click the POM, you're going to see something that we've been seeing throughout the course, and this is some tooling that has been provided to help us build our POM files. Here we see the Overview tab of our pom.xml file. It allows us to specify that parent if we'd like to come in and specify it now. We can also establish some properties. So if we want a custom property that we would like to put in our pom.xml configuration, we can specify it in this tab. And we can also specify modules if we are building a multi-module project. You'll also notice the name and description components over here. We can provide those via those text boxes. And then there's also some other information we can provide. We can provide the organization name, and we could provide a URL to our organization. And then it also provides us with some other integration with different tools. So if we were using a source code management tool, we could specify that within the SCM section. There's also issue management. So if you're using Jira or some other tool to track your bugs, you can specify those. You'll notice we have a Dependencies tab, and that tab will allow us to place different dependencies into our project. We've done this manually in the past. We can also take a look at the entire dependency hierarchy. We can see our effective POM. If you remember, we ran that help command to see the effective POM for application, but here we can just click on this tab, and this is going to show us our effective POM. So we kind of get a glance at what our POM looks like combined with any parent POMs and super POM. And then finally, on the last tab, we have the pom.xml file, and that is just the POM that we're creating for our project, and that's really what this file is. That's just some tooling that you can use. I'm going to save our changes to this POM file, and now I'd like to run through another demonstration of creating a Maven project using an archetype. I just use the new dialog, Control N, and I select Maven project once again, and this time I'm going to leave the Create a Simple Project checkbox unchecked. I just hit Next, and now it's going to ask me to select an archetype to base our new project off of. Well, let's make this a web app. Here I just type in web app, and if we scroll, we'll notice that it has filtered to a bunch of different archetypes that have the web app string within their name. So I'm going to go with our standard Maven archetype. So here's the Maven archetype web app. And we're just going to select that archetype and then hit Next. And you see it just downloaded it. Now, once again, we need to provide the group ID for the project that we are building. So once again, I'll go with com.infiniteskills.maven. And now for the artifact ID, I'm going to use m2e web app-demo. And then at this point, we should be able to build our new application. And here you'll see the package structure that it would like to use. And it's just going to take our artifact ID and provide some underscores. We can now create this project based upon that archetype by hitting the Finish button. And we'll see that we get a new web project added to our package explorer. And if we double click this POM, we can inspect it. We'll see that some of our POM configuration is already specified for us. So there we see our packaging is war, and let's see if we have any dependencies here. It looks like it pulled down JUnit for us, and then we can get a look at the dependency hierarchy. So there we can see all we're using really is JUnit 3.8.1. This is our first introduction to the M2E plugin, and it's just some tooling inside of Eclipse that allows us to use a graphical user interface to perform some Maven actions or some Maven commands. So it can really help guide us as we build these different Maven projects. The M2E plugin provides us with a great feature that allows us to easily manage the dependencies within our Maven project. In this lesson, we are going to use that feature to pull down a dependency that we will use within our M2E demo application. Here you will see the lone class in the M2E demo project, and we are going to use a library to provide an implementation for the isNumeric method. Before we begin pulling down our dependencies, though, I want to point out a small configuration item within the M2E plugin that can sometimes be challenging. When we look at the Dependencies tab within our POM, we can click this Add button, and from here we can start to type a group ID, an artifact ID, and what happens is we go out and search the Maven Central Repository and find all matching group IDs, artifact IDs, depending on what we type in. So here you see I'm pulling back a lot of Spring Framework artifacts that we can use within our projects as dependencies. One thing you may notice if you have just downloaded Eclipse is that you may not return anything at this screen. You need to change your configuration within Eclipse so that the M2E plugin pulls down all of the available repositories and indexes them so you can search them. So I'm just going to close out of that window, and I'm going to go to Window and then select Preferences. And within our options here, you'll notice we have the option to look at the Maven configuration. Now, you probably do not have Download Repository Index Updates on Startup checked. So check that option, and what this will do is it will go out to the repositories and get an index of all of the available artifacts and dependencies that we can download as a dependency into our project. Now, after you select this checkbox, just click OK, and then close and restart Eclipse. And it'll take a little bit, but you'll notice down in the lower right-hand corner, it will mention that it is pulling from the Maven repositories and getting the index. Now, once that is complete, you will be able to go to the pom.xml file and click on this Add button and pull down a dependency. Now, the dependency we would like to use is the Commons Lang 3 dependency. So here I'm going to use the org.apachecommons Commons Lang 3 dependency, and I'll just click OK, and then I'll hit Save. You'll notice the benefit of the M2E plugin is that I did not have to go out to the Maven Central Repository and search for that coordinate for this dependency. Now I can go over to our application, and I can use the string utils class to execute the isNumeric method, and then I can just pass in our test string. Now we are using that third-party library, Commons Lang, within our application, and we pulled it down via a Maven dependency. The M2E plugin will also resolve our transitive dependencies, much like our POM file did when we executed it via the command line. For example, If I were to add JUnit as a dependency, I can scroll down. You'll see there's many different artifacts out there. There's different people hosting JUnit, different versions of it. But if you would like the actual JUnit, you can go to the JUnit group ID and JUnit artifact ID and pull that into your project. And then what we'll see is that if we look at JUnit, we will have the transitive dependencies of JUnit resolved for us. So you'll see that Hamcrest core has been pulled in as a transitive dependency of JUnit 4.12. That's another great feature of the M2E plugin's dependency management. Now, one thing you may notice is sometimes you will open up Eclipse and you'll come in and you'll go to add an artifact or dependency to your project, and you're going to search for, let's say, a group ID that you know exists. So let's say I looked for the Spring framework and nothing returned. So here I got results, but sometimes nothing will come back. And I've experienced this issue a number of times working with the M2E plugin, and I have read about other people experiencing this issue. Let me show you a way you can correct that if you ever experience this. You can just go into your Eclipse workspace and go into the metadata folder, and then go into the plugins folder, and then you'll want to go to the M2E plugin directory. So here's m2e.core, and within m2e.core you'll see Nexus, and then you'll see all of these cryptic, I'm guessing they're hashes, folders. Just delete all of these folders and then restart Eclipse, and you'll see your repository index will rebuild. And then at that point, once you return to Eclipse, you will then be able to download dependencies. That's kind of a known issue, or at least one that's on my radar and that I deal with frequently, that I would just like to pass that common knowledge on to you so that you can overcome that issue quickly if you experience it. When working with Maven, it is necessary to execute different goals or phases against our project. By executing a goal or a phase, we set Maven into action to perform some task we would like against our project. When we use the command line, we just type in the goal or the phase we would like to use. However, when we use M2E, we need to use the Eclipse GUI to kick off a particular phase or goal. In this lesson, we're going to look at how we can execute different actions or tasks against our project using the Eclipse GUI and the M2E integration plugin. You'll notice that within our package explorer, we have the M2E Demo project. And if we were to right-click on this project, we can go to Run As, and you'll notice that we have some options here that are in regards to Maven. You'll notice the clean, the generate sources, the install, and test builds. These are 4 different predefined builds that you can use. So for example, I can run the install against our project. I'm just going to move my console up here, and you'll notice that we compiled and installed this artifact to our local repository. If I were to refresh our project, we see that we have the M2E demo 0.0.1-snapshot.jar file, and that was installed as an artifact within our local repository. It does exactly what we want package to do. But now what if we wanted to run some other phase or some other goal against this project? For example, let's say I just wanted to compile this project. Well, the first thing I'm going to do is I'm going to hit the clean goal here, and that will clean our project. But now we're just going to execute a compile. You'll notice we don't have an option that is predefined for compile. What we need to do is we need to create our own Maven build. I just clicked the Maven build option, and you'll notice it pointed my base directory to my project within my Eclipse workspace. If this were not specified, we could just browse in the workspace and select our project. And now I can just specify a goal that I would like to execute. So I'm going to use the compiler plugin, and I'm going to execute compile. Once I have that in place, I can just hit apply, And I could actually name this configuration, and I'm going to name it M2E Demo Compile. So I'll apply those changes, and then I can run from here. So here we will see that we will run the compiler goal, and it was successful, and we can refresh our project, and we'll see that we have now sources that have been compiled. Let's also change that up. I'm going to add the package goal into that run configuration. Now I can just click on Run Configurations. There's the M2E demo-compile, and then I'm also going to tell it to package after that compile. Okay, we ran our compile, and now we can see that we built our jar file. We executed the compiler compile goal and then the package phase, and that caused our jar file to be built. That was not an option previously available to us, and we defined it as our own build. So we specified the different phases we would like to run in this build, and we now have it available to us via the Eclipse GUI from this Run As option. If we wanted to, we could build some other type of combination here. So we could use clean and then compile. So I'll just hit apply and then hit run. And there we can see our clean was executed and our compiler executed. In this lesson, we learned to use the M2E user interface to execute different goals and phases against our project. Now, this is in contrast to when we're using Maven via the command line, where we were just manually typing in commands. However, one of the things we need to look out for when using the M2E user interface to execute these phases and these goals is that they are not all pre-configured. So we may need to configure our own type of build and specify the plugins or goals we would like to execute within that configuration. When working with Maven, we use plugins to execute different tasks against our Maven project. We know that Maven comes with a bunch of standard plugins that we can use, but sometimes there are particular actions or tasks that we want to take against our project that are not contained within those standard plugins. When we encounter this situation, we need to add a plugin to our POM file. In this lesson, we're going to learn how to use the M2E Eclipse plugin to download a third-party Maven plugin so that we can include that plugin within our POM file and have that plugin's tasks be executed against our project. The first thing we need to do to get started is we're going to look at our M2E demo project, and we're just going to right-click on the project, and if we go down to the Maven option in this menu, we can then click on the Add a Plugin feature, and we will get the Add Plugin dialog. Now this looks and works very similar to the dependency dialog. What we need to do is we need to specify our plugin name, so the artifact ID for our plugin. We're going to use the Maven Release plugin in this demo, and we want to select the Maven Release plugin with the group ID of org.apache.maven.plugins. Just click on that artifact and then select OK. If I expand our POM file here, so I'm just going to minimize this at the bottom, you will see that that plugin was then added to our pom.xml file. Let's talk a little bit about this plugin and we will demo it. We added it via the M2E Eclipse integration, and now that it's in place, the Maven Release plugin will actually update our POM file's version. What we can do is we can use one of the goals within that plugin. So here we see our version right now is 0.0.1-snapshot. And if we were to go to our Eclipse setup, we can run a Maven build, and we can now specify some goals that we would like to execute. So I'm going to call this M2 demo version, And then for the goals, we are going to execute the update versions goal on the release plugin. So we just have release colon and then our goal of update versions. And what we'll see is that when we run this goal against our project, that we will have our POM automatically updated for us. So now if we look at our POM file, we see that our version number has moved to 0.0.2-snapshot. This is nice to bind this goal to a particular phase's execution. And then with that, you would never have to really update the version of your project. It would just happen naturally. That's a look at a new plugin, and we just kind of use that plugin to demo the M2E Eclipse integration's ability to add a plugin to our project. You see, it's pretty simple. Unlike adding it manually to our POM, we don't have to go out and research the coordinates for our plugin. We can just search for it via the dialog provided by M2E. Now, one thing about this, M2E does not provide a way to configure this plugin. So let's say you wanted to change some of the parameters provided to this plugin, you would still need to manually work with your POM to set those plugin parameters and configure that plugin how you would like. Congratulations, you've completed the course. Let's take a few moments to reflect upon some of the things that we've learned and kind of look into the future to some areas where you can continue to improve in this area. First, we learned all about Maven, which is a build tool. It's a replacement or an alternative for something like Make or Ant. However, Maven provides us with additional features that were not available in something like Ant. And that's really the driver for using something like Maven. Now, Maven takes a different approach than other build tools. It uses convention over configuration in order to make builds easier. And we saw this throughout the course because we had those standard directory structures in place. Maven knew where to find our code when we executed a goal or a phase, and it allowed our plugins to perform, those useful tasks for us, simply because we had our code structured in a certain manner. Now, with that in place, that really made our builds easier. We were able to compile, package, install, and deploy a project simply with one command and the adherence to those directories. Now, we also learned about the dependency management system in Maven, and this is one of the biggest benefits. It allows us to pull in different artifacts or third-party libraries very easily because it resolves dependencies for us. So if we pull in Spring, we're not responsible for going out and finding all the libraries that Spring uses and putting them on our class path. That is automated. And that is so powerful. It really encourages you as a developer to experiment with other libraries and to use other people's code more. So you're using more third-party libraries, you're getting more reusability, and you're being more productive. And that's all because this dependency management system eases the use of those other libraries because all of the dependencies are managed. Now, as we've just touched on, the standardization across projects using Maven is a superior benefit from other build tools. We know that projects are going to look the same and that our builds are going to be performed in the same manner. This standardization or this predictability is very important because it allows us to move developers from one project to another. You can pull somebody into your organization, and if they know Maven and you have a portfolio of Maven projects, they will be more likely to be able to just be kind of plugged in and be productive. And then finally in our course, we looked at some of the tooling. So how the M2E plugin integrates into Eclipse and provides you with a little bit more of a GUI approach. And that can be helpful for those of us that are just getting started that may not be as comfortable using the command line. So now we have these great new Maven skills, but what do we do next? How do we keep improving now that we have this Maven tool within our toolbox? Well, the first thing I'm going to advocate for is that you take what you've learned in this course and you apply it somewhere, whether that's in the workplace or personal projects or going to Stack Overflow and answering questions. Continue to gain familiarity with the tool and learn the ins and outs of it. There's always small little discrepancies or bugs in a piece of software that you can only discover through experience. And I would urge you to continue working with the tool to find those areas. Next, I would encourage you to find other plugins that could be useful for your project. Now, plugins are being developed as we speak, so it's impossible to cover every plugin in the course. The great new plugin may not be invented yet, but something could come out tomorrow that could revolutionize your project and maybe change the way you work. Keep an eye out for those third-party plugins that are being developed and look for ways to integrate them into your project so you can achieve efficiencies. Once you know Maven, you can work with other tools that it integrates with. There are a lot of tools that can be used in parallel with Maven, and a lot of them are in the continuous integration spectrum. Here I mention Jenkins or Bamboo. And these tools help you continually push out the product. For example, you can set up Jenkins so that when you commit to the source control system that you're using, it will run your unit tests and then kick off a build and deploy your product. And that's very powerful in that recent changes are always getting pushed out. And that's the whole point of continuous integration. And those tools go hand in hand with Maven, so I would encourage you to go out and maybe just see how that can be incorporated into your workflow. And finally, I'd like to say thank you for watching this course. I really appreciate you taking the time to invest in yourself and your skills. I really enjoy producing these courses, and without people like you who are taking the next step to improve themselves in this technical realm, I could not do what I do. So I'm very grateful to have you watching this course, and I hope you enjoyed it.